your laptop is workstation. It's workstation. I know. P station. P series workstation. Because it got a sticker. So I think for what's that for brand? What's that? One thing also to mind, you get the mask. Satu lagi, mask. Ada mask.
Ya, jadi one right.
Ini sini.
Jadi ini lah.
Sorry. One Two Logix.
Yeah, 26K. 26 kilo.
One years.
Dia kena tangkap dekat Malaysia.
Dekat Indonesia.
Malaysia.
Key.
Now,
Ya.
dia beritahu this from, I mean, orang yang distributed IBs, I see the nature orang distributed from
Malaysia.
Selangor lah, Selangor punya area. Dia suka Batam. He said they offer 50K.
Ya, 50K.
50K. And now the question is, how, macam mana dia boleh lepas from Malaysian airport?
Ya.
So that is the now big issue.
Dia sebab dia pilot kan.
Jadi pilot.
So, itu golongan yang I don't think I think a lot of people doing that.
Last time apa dia punya dekat immigration KL ni kan? Apa I think sama kawasan lulus dia pergi check ada pasport, ada fake pasport on the ceiling, dia orang simpan immigration. So semua kena tangkap.
This easy money. I think this is not first time.
Same thing, you know the Malaysian court in Singapore and
Yeah.
same thing.
Here, right?
Yeah.
In Johor.
I mean, some Johor lah, some who come for, you know, work in Singapore.
That time one case, right? The teenager, I think he's 17 years old, also bring the hearing.
Yeah.
Go to the.
I know my younger brother's friend.
Oh, his
You know,
friend.
his friend last time
Oh,
kena hand.
right here.
Yeah.
Yes.
Because he, I think, from 3 something he stopped going. Okay. I mean sekolah rendah, I mean classmates lah.
Right.
Then from 1, from 2, from 3 he studied. Then after from 3 he stopped. Then he start to work lah. Start to work there.
Make this kind of
Lorry or that. So then suddenly he ended up in Singapore. Then he worked in Singapore. But big lorry, you know. He drive lorry, just the lorry license, everything. At that time, I think he's just 19 years old only when he get caught. 19 years old. Then that time I was studying then and I go back to my hometown lah. Then my brother told me this one got down. Then after how many years? After 5 years. After 5 years. This one, but from his friends lah. Okay, then what my brother told me is they force him to bring something.
Oh, so then okay, initially give you money, give you money, then okay.
Then once you see the money, initially you bring a small, okay. So you don't know. Small. Then once, but they don't know that here they have informers here. They don't know.
Yeah.
If no means how they can record. Many people are looking, what suddenly why you do that? Yes. Sure. Because I know last time I go convoy from motorbike from US. So that's why the guy lah he work as an ASCA. Okay. Then sometimes they give you task, you know, to follow someone. So he told me how they follow, you know. Let's say you are going from for example, from your hotel, you are coming here. Okay, for example, so from the hotel, you go makan. One person will follow. Then from makan place, let's say you're walking up. You come to the next building, another person will follow you. So from there, this one short distance lah. Let's say you are going to a mall, right? Something from your house to your mall. Easily, 4 or 5 people will follow you. That's how they try to they see what you're doing.
They spy everything. You know, yeah, inside the
That's how they do. I thought only the police do.
I believe this one the pilot thought that they have the packages.
Yes.
Okay. Bypass something.
Bypass, yeah.
Or sometimes you have these privileges. They end up this. You don't get caught one time enough ni.
Yeah.
Yang ni saya dia nama yang kali lepas lah.
Yeah.
His success many times.
Many times, yeah. If no means how you can bring 26 kilo.
Yeah. But I think initially it brings small bags.
Small bags and one time.
Oh, easy money ah. Easy money. Yes.
Belum. So in your project, right? I mean, once you save everything, like yang desktop, this backup lah, you can delete actually. Once you already save, finish the project, everything, backup all you can do. Delete. Okay. So you create a new project.
You have to keep this last part.
The .acd only enough. The rest backups all no. A4. So you put a new project A4 lesson 1. So we see some functions lah, how the function goes. You want studio version 32, right?
Yeah.
Okay, then you create your PLC, add your PLC, then you add your compact bus local. No, here, the compact bus local. Yeah, right click, new modules. So inside that, it's got 10 part, in a compressed file, 10 part, you only decompress the first one, extract the first one.
So the installer will decompress
The whole because I think very very hard to find somewhere in there.
the older version.
So this one all your case is fine from got from Mexico, right? Okay. Now, for now, the start already now. When we are not using any IO first, because we want to learn. Let's see. You already learned the scaling, right? This scaling, the move. Okay. So we see maybe okay, never mind. You go to control tab. You add you add the push buttons as a sensor 1, sensor 2, then reset. The 3 push button. Sensor 1, sensor 2, reset. You are not doing in your main routine, you create a routine. You put a counter program. then you go to the main booking. So you add this. Double click. Just double click the JSR. The click the jump to start. Okay. Now go to program. Okay. So what do you do? Put how many opens and so on. Yes. Then the output is a counter. You click here. Okay, you can use a CPU counter up here. Okay. So counter similar like your timer. Okay, this is a counter up. It means once I reach my the preset like timer I need to set. So once I reach my set point, the done will on. That is a counter time.
So it can be anything regardless of timer or what.
Which one?
This CDU. It can be anything, not only timer lah. Like any set point lah. For example, like float switch or something like that.
Yeah. Can be anything.
Can be anything lah.
Can be anything.
If I reach a certain set point, you will trigger anything to what?
Yes.
To true lah.
So this one can be because timer is I give timer something like this, right? So I give the input, it count, right? It will count according to my value, then give me an output. Counter means it can be like every time this line from 0 become 1, I count 1. Then again, then if this 0 become 1, I count 2. So it can be anything, you can use for anything. So you want to use, let's say, for example, like you are doing your right line, a lap. Okay, how many lap need to do? Once I finish this 15 lap, okay, then I slow, I cut off, something like that. I think your system should build F, I think maybe I'm not sure.
We have like a daily test in the morning. We do a stop test. They will come out of the system. Each day, that daily startup, that daily test will reset by itself each day.
Okay.
So in the morning, our technician will do the stop. Maybe around 10 minutes, do the solar stop.
Yeah.
Okay, there's a lot of things we need to clear. After we clear, we will break test everything. That timer will start up to brand new, like 24 example, 17 hours. Okay. That thing will count down until maybe midnight. It will reset by itself again. Zero. You have to do another daily test again. I think that one is a timer, right?
Yeah. That one is a timer lah. That is a timer. When counter, it depends. I think what to count is just a counter.
So if we
So it's like your right or something.
like something deviate to some to a certain value.
Yes.
CDU the stand for counter
Counter up.
Counter up.
Yeah. Then you have a CTD. That one is like counter down.
And then the threshold they will trigger
Yeah.
like a fall lah. Can trigger this one for fall also lah.
Yeah, of course.
Ah.
It's dependent. So the counter is it count and give you an output. So how you want to use is dependent on you.
You can set value.
Yes. So how you want to use, when to use is dependent because the counter job is I count and give you a boolean. The boolean is your counter time.
But only on this line, right? Or
Which one?
for this counter,
Mm-hmm.
it's only for this run only, right? Or you can take
No.
another round.
Okay. This counter I will count. Then after the count I give the counter done, right? So the done you can use anywhere. Okay. So
So
just
this is on boolean only.
yes, it's a
Must
boolean.
be digital.
It's a digital lah, digital signal. Okay, so now when you put a name, maybe a counter one, a new name like timer. Timer you create a new name, right? Same as that. You put a value, how many products? Put 5 in a. Put 5, count. Accumulated lower, accumulated 0. Because it's the accumulated result. Okay. So I count then the counter done is on. Then I can use the done to on something. Okay. Okay, maybe okay, you click here.
Why can my counter set the present? Because I also already carrying an tag, but it cannot.
Okay, wait.
Cannot. I already create a new tag here. Is this setting on wrong?
Yeah. Because you put here counter,
Okay.
but here the name is counter 1. Not the same. Okay. 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 You change the name here. You know what happened just now? You created counter space 1. Right?
Okay.
So when you create, it just create the name counter only.
Oh yeah, true. I displayed it here just now.
So now only you add, right? Bila you tengok sana, dia jadi counter space 1 kan?
Space one.
Space 1 tu dia. Yes. Okay, now. Okay. Then you click one round. Then you can use normally you click one round below. You put normally open counter 1 done. Counter 1 done means the counter delete. Delete. Okay, then you put the output. Yes. Put one output. Okay. Maybe because we don't have any output, I want to create new. But I want to create new output here. Okay, I don't want to create the control like. Okay, just put let's say lamb 1. Okay. I want to create a physical output. So once I create lamb 1, I put here alias. Choose it. Choose the alias. Because like we are creating the tag inside the program. Normally you create in the control tag first, right?
But we can create another way around.
And this also can. Then alias. Then is what local output is. Data 0. Okay. So very simple lah. So when the sensor hit on and off 5 times, I on it. Okay. So we are just want to learn how the counter works. Then it's depend on you how we want to use the counter. Okay. So for example, let's say I have a bottle. This is a sensor. Okay. 5 times I count. Then once I reach the 5th bottle, the lamp is on. Okay. To indicate this is the 5th bottle or something. Okay. Then after that, I need to reset the counter. Correct or not? Because the counter will stay at 5. Because like timer, if you see timer, how the timer works? Okay, see, timer, okay, I have input TON, let's say T1. Okay. So when I'm using T1 done to on a lamp, okay. So I turn on the input. Let's say I'm using a 5 second. So when I turn on, the timer will run for 5 seconds. After the 5 seconds, the done on. Right? So the done can on the lamp. Okay? If the input off, the timer will reset. Correct? Then this one will off. That's how the timer works. Correct? The timer, how the timer works? When there is an input, I will start the counting until I reach my set point. I energize the timer done. If the input off, I will reset. Okay. But here you see the sensor is on off, on off, on off. So how the counter can reset? Cannot, right? So they must use a reset function for the counter. Okay. So you go to the 3rd line, you add another line.
Oh, that's how the counter works.
Okay. Then you put a normally open. Just now you create a reset push button, 3rd one, right? Normally open. Alright. Okay. Then to reset, you go to the counter. Timer and counter. Can you see got RES?
Yeah.
Okay, you choose that. This one is to reset the counter and timer. Okay. Then put here the counter name. No. Click here. Here you must put the counter name. Counter 1. Yes. Yes. Okay. You save, download, you test.
Or you count how many times the sensor will trigger something.
Yes,
That's
yes.
how that's how the counter works.
Okay, to go to communication part needed, right? Okay, there's no part. So you choose which one, then you can download.
Do you also need another version? Add another version of software.
What?
Version of RS Studio. You also want another version?
What version you have?
I think something version 33.
Yeah.
You have, right? What the versions do you have?
I have when I just got you can see what on the machine, but I mean the studio lah, the RS Logic, I have version. I have 21, 23, 24, 26, 28, 30, 31, 32, 33, yeah.
I find it 35.
Oh, yeah, 35. I even my case I have that. Your case is have until 30. Here also you have until 30. Yeah, I have, but the thing license only. I only have for 20 and 31. I mean the full practice.
I also got an inspector.
For which one?
You can try it.
Or it is the cut or the studio 35? The thing is, because you want to activate the license, when you install they have one software called Factory Talk license. Okay, Factory Talk. Yeah. So inside there you need to add license. What the cut means and how it works. Other guys you already have the license everything, put in there. Then when you add the license right, in the folder, it will create one file. So they will use that file to patch it.
We use it for multiple license.
Otherwise, every version you need to have the version.
Expensive. Not sustainable.
Yeah, because for you, no.
For that, saya standard saja.
Because for a while only you want to open.
Walaupun troubleshoot,
That's a troubleshoot. If you're doing project, okay lah. Let's say you are a company. Because for us, we have the license, but we don't have for all the version. So my boss last time buy for version 20, we all got the license. The portal for 15 got the license. But the license for 15 you can use for other versions, no problem. Then same, each one you already have one license. Of course, I cannot install for all. So normally whenever I bring my laptop, what happened last time the Siemens license my boss laptop. So after you retire, I transfer to my laptop.
so they do that. So
That's one can transfer. So I transfer to mine. So because this is the laptop I bring for troubleshooting. So if anyone asks, I have the original license.
So Siemens one can share.
No, shake and share. Similar is easy to use.
Easy.
Easy.
Definitely. Definitely, dia sampai ke your laptop.
Yeah.
So the second time you want to install and uninstall, just
block you.
that's why I use washing machine.
Virtual.
Yes, I use virtual.
Dia tak video.
Hardware.
You want TI 20?
Can
Yeah.
you can put it terus masuk
Yeah,
dalam. What version you have? 22 you got that?
TI.
How much version that?
At least I've got version 20, 22, 24, 26, 28, 29, 25, 25. Yeah, at least. Too strong, that's the problem.
Itu dua version ni tak ada.
Tak ada. Tengok. Kalau perlukan version,
Dia tak ada. Jadi itu.
susah. Order version.
Older version very hard.
Susah.
Kita tak ada.
So what you can share.
And TI portal version 20 also, one of my participants gave me. So last time he come and learn, I think during COVID time, then he come and learn and from KL. Then after that, after COVID, he joined a Singapore company. He was working there. So at one time, he got on a project. So the SCADA from the older version to Siemens, the older WinCC, he converted to new WinCC. He do everything already. There's one problem he faced for the face plate. We call it. Face plate means like a template. You create one template. Inside there, you put all the buttons, everything, to make it into one new object. So that one you can copy multiple things. Let's say you have 10 motor, right? Start, stop, motor. For example, 2 button, 1 line. You don't need to create one, then again. So you create 2 button, 1 line, and make that 3 things into one object. Your own object. So they can, it's a template, right? But in SCADA, they call face plates. So, face plate. Then you can use multiple. So that's the thing he don't know how to create. Okay. Actually, I also don't know. He come here, he asked me, then I say, okay, give me some time. Let's go to YouTube and see how to create. Because I never heard first face plate before. Then I say, oh, like this. Okay. Then I teach him. Then there's one thing, the tagging, he got some issue. So then I showed him how to do that. Once done, then he asked me, because he's using 20. Then I said, oh, you use 20 now, okay, good. Then he said, do you want 20? Yeah, if you have, you give me 20 full version, you know. Full version, because the license you can get very easy. But the installation, we have portal professional, the start drive, and the WinCC professional. Portal,
The professional one, but that is standard. I think standard is separate.
started separate. Because the WinCC professional is important because WinCC professional include the SCADA.
Yeah, true.
If the WinCC comfort only, okay, because it's just for HMI to use, but the SCADA is not that. So it will be WinCC for professional. But now they changed the name already, WinCC. They put a new one, right? They put WinCC Unified.
Oh,
PC. They call WinCC Unified PC. So the thing you can put in your HMI also can, and it can be as a SCADA. It's a web-based.
It's supposed to do that. If you go to the website, so many apps. I also don't know which one I should pick.
Yes.
So confusing.
Yeah.
Like you said, license maybe easy to take, but
The software,
there's a
yes.
way to pick which one is which one we should use.
Which one you
No.
that's a problem.
Ah.
So many. Then that day only, then I see, why inside here no professional, no. Then I see, they unified. Then I go to Google.
It's about the start drive. Do you have any older version of start drive?
Start drive.
Starter.
Starter version 5.4, I think. I checked.
The older version.
Later I check and I show you which one. Starter.
Starter is what?
Yes.
Starter is the software for the VFD.
Oh,
So to do the parameters. Because of the parameter already, they just upload the parameter, put into a new one.
Because like our right, you cannot simply just upgrade anything.
Yeah, of course.
Everything is got service nature, everything is being recorded.
Yes.
So we have to use some older version of software just to open and see if it's correct. Okay.
Yeah. Sometimes, it's the old. Sometimes the software can support Windows 10, 11. You need to go for Windows XP or Windows 7.
oh.
That one only. Okay. This one can counter.
Yeah.
Okay. So you count 5 times, it can on, right? Go up. Program will go up. See. So you count 5 times. Okay. Then you reset. If you more than 5 times, what happens? You go more than 5 times. Okay. So it can keep on counting only.
Or it can start anytime now. I have reset.
Yeah, the reset any time you can reset. So it keep on counting only. But my counter done will be after the 5. Okay, not after the exactly at the 5 lah. The accumulator can go up to what value?
999.
No. Go to controller tab. Okay, this is where we want to learn the data types. Today we learn more data types.
It depends on the double integer.
Yes. You go to counter 1.
Many lah. Double pun banyak.
Yes. So you see here, the accumulator can go up to double integer. So the double integer means it can go up to 2.1 billion positive value. You can open my slide. Inside my slide, we have a table. The data type table. Go to eliminate. Yes, eliminate.
2 something billion.
2.1 billion.
Billion natural. Single integer is only 8 bit, right?
Single. It's not single. They don't call single integer. It's a short integer.
Short integer.
It's a 8 bit.
8 bit. 8 bit.
8 bit is the maximum is 255.
2.5.
Okay. Integer is 0 to 655. But Alan Bradley, they're using this one, sign. They don't have unsigned. Alan Bradley, they always use the sign. So in Alan Bradley, if you see INT, it means it's sign.
Okay.
Kalau dia tulis UINT, then only it's unsigned. In Siemens, they use both. In Alan Bradley, they use the sign.
Sign anything about negative number.
Negative to positive lah. Okay. You know how I get these numbers? 0 to 655.
I'm not sure.
Okay. So you see, we have what we call how many bits?
16 bits.
16 bits. Okay. So this one just because then only you can get how it works, right? Because we know yes, because this one is very important later for our Siemens program. So there is a bit 0, bit 1, bit 2, bit 3, right? 6, 7, okay. So you need to this one, if I want to convert this into binary, you need to convert to 2 power of 0, 2 power of 1. Okay. So 2 power of 0 is 1. 2 power of 1 is 2. So this is 4. 4. So this is 8, 16, 32, 64, 1 to 8. That's okay. So what happened? When you key in some value inside, okay? When you key in some value, even later also you can see. Let's say I key in just now the counter value 5, right?
Yeah.
5 means this bit and this bit is on.
So you only use 3 bit.
Yes. So the rest of the bit will be 0, 0.
Okay. 3 bit or 2 bit? Consider all 3.
Don't count that way. How many bits? It's under, because the 5, okay, I'm using a 8 bit or 16 bit or 32 bit.
Okay.
The first bit 1, second bit 0, third bit is 1, the value is 5.
Okay.
Okay. So let's say I need a 28. So
Just that.
16 plus 8 is how much? 30, 24, right? 24 plus 4, right? 28. 0, 0. So that's how it works.
Okay.
So if you see this here, I put it up until the 16 bits
Okay.
here. So 1, 2, 4, 8 until 1 to 8, then 2, 5, 6, 5, 1, 2. If you add all these 1, 1, 1, 1, 1, 1,
Okay.
you will get the 6, 5, 5, 3, 5.
Oh.
So that's how the 32 bit also works. So here now bit until bit number 15 from 0 to 15. Then 16, 17, 18, and the bigger number. Okay, so that's how it works. Okay, go to your article. Go to monitor tab. Counter, you think, this one, right? The accumulator. You open. You make it bigger. This one. This is the name. Yeah. Okay, you see, counter accumulator dot 0 until 31 lah. Right? Okay. So total 32 bit. Okay. Now you press 1. The first one will on.
This one?
No, you press the button. The count.
Oh.
Okay, the first one on. Okay, you count. Okay, 2. So basically, you see, this one 1 is 1. This one is 2. Now both will on for 3.
So you will activate according
According to the bits like binary system. That's how it works. Because it's a computer. So PLC is a computer.
So which means that the integer allow you until 5K or somewhere.
Yeah. That's why I did. You remember that the 65K, 32K, right? It's enough already. You need to remember the whole thing.
So AB only using sign, right?
Yeah. Because you can't find, you go here.
Then which means that the number is half only.
Yeah, half. This one only.
Because negative usually 7.
Yeah, of course, we will use for counting. All that.
Unless we do a reverse thing, then we use it.
No, not necessarily. Let's say very simple example. You have a temperature sensor, which the range is negative 50 to 150 degree. So of course, in your calculation, you will have a negative value. But it depends on how frequent you want to use. Of course, there are negative numbers.
But the ones, because this kind of sensor using analogs.
And of course, analog.
It's not using digital. Right?
No.
Because Windows is the digital.
Yeah. So 1 or 0. Okay. But the analog also, of course, I get the data will be in integer format. Will be in the integer format. Okay. But it still integer is 16 bit, right?
Yeah.
So that's how it still works. Still it will be like 1 0 1 1 1, but it's like total of 16 bit. Your boolean is only using 1 bit. Analog is using 16 bit.
Oh, analog using 16.
Analog using 16 bit.
Oh.
So it still will be, but still be a in binary system only. For us only it become like a value. But for the PLC, it still be a binary numbers.
Yeah, I thought there's analog using like ampere, right?
Yeah, of
4 amps,
course.
4 milliamps to 20
Yeah,
milliamps.
so, but you will get the 4 to 20 million to the piece, the analog card. My function of the analog card is convert that milliamp things into a digital number.
The backend conversions.
Yes. Okay. That's why normally like Siemens or Allen or like analog input they just call AI card. Yeah. If you see Japanese PLC, Mitsubishi or Omron, they put the card name is analog input, but they call AD. The part number they call AD. AD because it's an analog to digital converter.
I see. The upfront is analog. Then until PLC, they convert
to digital. This AD thing in Japanese PLC you can see this AD thing. For output they call DA.
So
because PLC give digital, convert to our analog.
They call it, just like machine calling
AD converter.
Oh, analog digital converter.
Yes, analog to digital converter. For output is a DA. Okay, you can see here this one. This is a Mitsubishi one, you see. It's a FX3U4AD. Okay, so got 4 analog to digital. So this is the input card. This one is a 4DA. So it's the output card, digital to analog.
So they will convert whatever voltage or ampere to the integer or double integer.
Integer not double. Any PLC, if you're using analog, it's integer. So the range always will be -32 to +32. In between that only. Any PLC you take. Okay, good. Okay, minimize this. Okay, go back to the counter program. Let's say I'm just counting up only, right? If let's say I want to count up and down. Okay, counter up and also counter down. Both, right? If you see, Allen don't have a counter up down. Like some PLC, they have counter up one function, counter down one function, counter up down one function. Okay, so Allen don't have. Allen have only counter up and counter down. So if you want to do counter up and down, okay, I'll show you how. You click here, you add one run. Yes. Okay. You put CTD. Yes, counter down. Then use the same counter name. So when you use the same counter name on the up and down, so the count will become like a counter up down.
One will give a positive number, one will give
one to increase, one to decrease. Okay, the value cannot change for it because if you follow this number, okay, the input you put normally open, then you put sensor 2. Okay. Then you accept and finalize. Then you play. One is to count up the value, one is to count down the value. When you count down, go below 0. You get negative. No, what license? What software? What version? You know? Yeah, you want. You have other logic ready.
This comes from Omron.
Ready lah.
The starter is
Exactly.
5.4 should F lah. Later I check should F. So you need 5.4 lah. Oh here I have. Sorry 4.5. 5.4. So it's 5.6. 5. So you need 5.4. 4.
How many need all the stuff?
Okay. Because I have another piece which I need to check also. Starter the version 4 dan version 5 lah. Jangan dia itu.
sekarang dia.
Let's go.
5.6.
5.6.
Later is 5.6. Okay, boleh je kan? Okay.
So you dah dapat complete version.
No, yeah, tak.
Not yet.
Not yet lah.
After 40 way.
Okay, counter okay? Okay. Now what we do, we go to other functions. Okay, go offline. Okay. So remember yesterday we used O and S one shot.
Okay.
Okay, so I will explain on today we use some others. Okay. So what you do, you create another routine. You create another routine, you name it as a pulse function. Yeah, pulse. Okay, now go to the pulse function. Okay, I want to create a simple program first, then from there we try to crack the idea. Okay, what you do, before that you go to controller tag. Go to controller tag. Okay, so the three switches, right? So you put as switch 1, switch 2, switch 3, the switches, because just now you already have sensor 1, sensor 2 reset, right? So you put the switch 1 for switch 1, switch 2, switch 3. Then for the lamp, maybe you add one more output as a pump, for example. local I data 0.
Another is lamp cooling.
No, just put pump. Just put one pump. And later want to change, always change.
For the input, right? We have data and fault, right?
The fault is like I said, the fault, right? Inside the fault, okay, we don't see here, we see somewhere here. Okay.
Yeah, this one I just don't do that.
Okay. So fault we cannot do it. It's never. Just cancel it. Wait, enter first. Then only can delete. Yes. You need to complete. You need to create first. Then only can delete. That's always one problem. Okay. Now you click here. Okay. Fault, right? Okay. Fault now you have 32. Sorry, 31. 32 actually. 32 boolean lah. 32. So, but it's not won't work like the data lah. Okay. The data means the value. The fault means whatever you need to refer to the manual. In the manual, what they say is for fault, of course, you have a 32 bit, but if the cut is failed, so if you give you like the first bit is on or something like that, it won't use the whole 32 bit. Only use some bits to show that module is faulty.
Okay.
So when you go to their manual, they will give you which number. Maybe sometimes it's like a 101. Bit number 1 and bit number 0 and bit number 2. On means is for what? Low voltage fault.
Depends on the
Depends on the
device.
what type of fault. Yes.
So, like example, I use a motion controller.
Yes.
On that fault, there's a fault for that. Depends on that one.
Yes.
What will send here? Something like
Yes.
that.
It will send here. So, for example, now in the cut, in the input cut. So, what is the fault maybe we have? Sometimes is what high voltage maybe. Suppose it be 24 volt, but higher voltage. Okay. Or the cut is burned or cut is faulty, something like that. So, a few fault only you will get, right?
Okay.
So, for each fault, they have a number for that. So from the manual, you need to get the number. Then only we can use which one you want to use. So for this one, we will check. This one is what? Maybe we can try and see whether the fault is 1769 I-Q 32.
32.
32, yes, sir. Fault code.
For example, for the cut, but we have to manually place the fault code over here. Or even for the cut, only we don't have to do anything. Only for external device for this fault. Do we have to key in the external device for category both, like the cut including the external device, or just the external device?
No, it's on the cut only.
It's on the cut only.
Yes.
Which means that all this now you say the number, right? let's say low voltage or high voltage, it's predefined already, right?
Yes, it's already predefined.
Oh, predefined.
Yes, because I'm just checking the manual. If I get the manual, then I should.
But if let's say they already predefined, right? There's nothing much you can do, right?
Yeah, yeah.
There's nothing much you can do.
Because they already predefined. So you can't use that. I mean, you cannot modify it lah.
But we can see they've got HMI inspection solution.
Yeah, there's some things lah.
Sometimes the special look like this.
Include data file.
If let's say like, if let's say an example, let's say the cut field, this input cut field, which means that when PLC is not detected, then you will trigger, let's say 101.
Yes, something like that. Yes.
Just an example.
Yeah.
Is it possible that I can use this data to execute another functions?
Yeah, of course.
So this one we don't have to predetermine anything, right?
Yeah. No, it's already.
It's just for look only, it's just for read only. We only read and see.
We only can read the data.
Oh,
Read and we can use somewhere else.
like example, we add some instruction or something or tag lah.
Yes.
Can use for the tag lah.
Yes.
Yeah, HMI tags.
Okay, maybe we can try. Maybe you go to monitor that. You go online and monitor. We see. If the module remove whatever. Empty run. So you see there's one empty run. You check and delete. Delete first. Download. Because do some changes because you had a routine, right? There's not much. What they say is, okay. You see, you go to one, you go to run mode. Okay, yes. Okay, then go to monitor tag. Here you can see. Here, monitor. Okay, local one. Click here. Okay, then you don't open the font. Okay, make it bigger. We see in the binary number. Yeah, make it bigger because that's too big. Sama. Okay. You press the push buttons, then you can see the 1, 2, 3, 4 here. Okay, right? Okay. Now, if I get the fault, what they say, because I take the manual, I put the Gemini and check. If the fault value, like the inside double integer, the fault value, if 0 means no fault. Okay? If I create a fault, then I will get some number here.
Yeah,
Got right?
got.
You just remove you remove the add cap. You know the add cap, the last one. You remove the connector. Yes. No, the connector is. That one you need to push full back. Yes. Okay, enough. Ethernet come out. Okay. Okay, right. Clear, okay? Try and go online again. Okay, you see? All become one. Okay. You connect back. Okay, because the controller is altered with the show. Okay, we click here. Go to fault. Go to fault. Okay, you bring down here.
Sure.
Okay. So clear major. Okay. Then make it to run mode. Change back to run mode. See, all becomes okay. So something like this you will get.
Oh.
Just they don't have like each out or 32 input, right? Each input fail. They don't have. They only have the card fail.
So example, if I want to make a sensor trigger more than 5 times fault, I have to use another method.
Yes.
Oh, okay.
Same goes for your output card also same. Close here. Okay, for the output card, you have C. C, right, is a configuration and program mode, fault mode, everything. Okay, then the two also got I input, which is the fault, the same thing, lah.
Yeah.
Same fault just now we looked at, same thing. So means each card they have their some own diagnostic things. So if you want to use, you can use that in your program.
But usually they just pop up the light already, right?
Pop up the right way, but how to say? It pop up the light, yes, but for this compact logic lah, normally if the card is failed, of course the controller will become error.
Yeah.
But for control logic, it's not like that. If the card is failed, the PLC still can run. Because it's running on the back plane. Later we set up that.
So this one usually we seldom use it for config.
Very rare we use. This one also same. They have their own meaning. So you need to check in the manual lah. Need to download manual, need to see.
Usually we seldom use one.
Very rare. Because normally we don't use it's just the card fail, okay, card fail. That one is easier. Unless it's an analog input card. An analog input card, because analog inputs can read like wire break. Because you must have a 4 to 20 milliamp two cable. If one cable break, it becomes 0. So for that, yes, they will have like wire break. That's for the alarm, the for fault. Then you for analog, you can use that faults. So the channel, the first
But
input,
for digital, it's
no need.
Usually they use different method for this one.
Not this one.
Different methods.
Different method means okay. How? Okay, what you want to check on the input card, for example. Okay, if the input is detecting or not. Okay, so normally, that's why I say that's why it depends on your program how you want to run. Okay, like this. For example, let's say you have a ride. Start from the point A, it goes and need to come back to point A. So let's say that there's a sensor here. Okay, there's a sensor here. So let's say, no, here I start, and here got one sensor, and here got one sensor. So this sensor, according to your right, some everything, from point A to point B, within 10 seconds, I need to reach them. So means when I press start, at the back, I've run a timer. Okay. So within that timer, I need to reach that position. If I didn't reach that position, it means either I slow or the sensor is not working. So I need to create some logic there.
So if the requirement of example 2 point,
Yes,
and then you run. If one of these point fail,
yes,
it will go another branch.
yes,
Figure out one fault.
yes. So something like that.
Something like that.
So that's how you create the fault.
Because I pernah tengok
Yes,
dia tak pakai ini.
they don't use the this.
Yeah.
This one mostly, that's why I say, because if the card fail, all become one. So that's a data only. So what I do, if I want to use this, you just use the first bit enough. The first bit is on, the fault dot zero is on, I create alarm. Then in the HMI I show alarm. So then I cannot be like very specific, okay, the 0.0, 0.1. They don't have that. What they said, they said you don't support point level diagnostic. 1.1 point level diagnostic don't have. Only the whole card.
Another question, if let's say for close sensor, usually using non-close.
Sure.
For sensor.
Depends also.
Depend.
If let's say what we want is the safety for safety. I want constantly monitoring.
Can also.
So is it that's recommend using non-close?
Depends.
Depend on the sensor, but like what you said, also is a valid point lah.
Yeah.
Means if normally close means okay, of course the sensor always gives signal lah.
I always monitoring, constantly monitoring.
Constantly I get the signal. Okay.
Yes, yes.
So if there's a wire break or something, so I don't get the signal. So I know something.
I'm
about-
monitoring the whole line.
Yeah.
Instead of the sensor trigger.
Yeah, something like that. You can use. That's why normally like emergency stop lah, they use normally. So any sense, like you said, like any sensor or any input I want to constantly monitor, then I use normally close. Any sensor is I want when I trigger, then only I want to monitor, then I use normally. That's why the push button normally, I mean the start. If you see your systems, the start button, everything, will be normally open because you initiate the function. If the cable is not, I mean, if the cable break, it's not working, it's okay. Because when you press, it's not running. But if you see sometimes the stop button normally close, some sensors they use normally, stop button emergency stop, some sensors are they use normally close. Because they are for safety. So if the wire break means then I know okay, there's a problem or something.
So usually whatever related to safety, then we would use non-close.
You cannot conclude like that, but it can, it can do like that lah. Yes, it's based on design. Based on the design, based on the sensor, how the sensor works, because of course, like you say, any 6 sensor normally, I mean a normal 6 sensor to detect this, for example, bottle, right? Because the sensor you have normally close type, so what normally open type. So it depends on how they design. Okay, good. Okay, now go to the pulse function, right? What you do? Just now you have what? You go to edit tab. Go to the edit tab. You close this fault.
Switch 1, switch 2, switch 3.
Yeah, then the pump, right? Okay. So what I want to do, okay, when switch 1 is on, okay, a simple example. I have this bottle, I have this sensor. Okay, when the conveyor running, the conveyor thing we don't care lah. Okay. When I come here, then when the sensor detects, I want to on a pump to fill in. After 10 seconds, the pump need to off. But sensor will be here only. Okay. Sensor will be always on only. The pump need to run for 10 seconds, then need to off back. Okay. So how I do it? I switch on, pump on, right? Then I can use the pump to run a timer off. I depend on how you. I just want to use a T1 lah. Okay. The T1 and T1 done. This one I don't need to latch lah because this is the switch, right? Try to do this program and you test and see what happens. In your pulse machine. Okay, on the switch, whatever.
You continue counting.
Continue counting, right? Not off, because of this one is always on, right? So this is where yesterday we also received the bar structure, right? Okay. Now you go to offline first. Offline. I do, because when I on the switch one, I have some problem, right? Because it's always on. So you right click here, right click, insert. Okay, what you do? You copy paste that up. Copy and paste again in the same zero, yeah. So you paste one below, okay. And this one you delete. The switch one and the pump you delete on the first line. The switch one timer here. Delete and the pump. So what I want to do is, okay. So when I use switch one here, which is always on, I cannot run the pump because it's like continuously running. Timer like keep on running, right? Okay, because of the switch is always on. Okay. So what I want to do, of course, like, because it's already detected, so the switch is always on one. Okay. So I cannot change the switch, the sensor like the sensor. Okay. But I can modify in the program. So what I do, you go to bit. The one shot later we try lah. Okay. Can you see OSR, OSF? Okay, OSR, OSF means it's a one shot rising, one shot falling. It means you see when Boolean, right? Boolean have 0 or 1. Right? Boolean have 0 or 1. So when 0 is always 0 lah. When it's 1, it become 1 like this. Then it become always 1, then become 0 means become. From 0 to 1, the movement from 0 to 1, okay, we call OSR. One shot rising, only one shot. Okay. From 1 becomes 0, they call one shot falling. So means like we take only one shot, means like on off. That's all. Okay. So use the OSR first. OSR. Okay. So the OSR got two bits lah. One is the storage bit, one is the output bit. Storage bit means if you store the number lah. If the switch is 1, the storage bit 1. If the switch is 0, the storage bit 0. Okay. The output bit is the one become like pulse on off. Okay. So what you do, you just create a two name. One is the storage bit, one is the, you put S1 output bit. You create two new tag.
For storage,
You just put, you can put S1 storage bit. Yep. You can put SB also. Okay. Now what happens is when the switch is on, the output bit right become pulse. On off back. Okay. So you replace the switch one and replace to the output bit. The switch one to replace with the output bit. Yes. You need to time and count this. Okay, but you need to latch it because this will become a pulse ready. Because from the switch, I give the signal to the OSR. So the OSR keep the data in the storage bit, and the output bit become like on and off. So here also become on and off. So you will latch it. Do online edit, you latch it. You see, it looks like not on, right? Like you off the switch, okay, on it. Okay. You see this bit, this looks like didn't on the
Too fast.
too fast. So this is how you use the one-shot function. It's a sensor trigger or some signal which is like always on. The signal is always I receive. But I don't want the signal for that particular logic. I don't want the signal to be always on. I just need one pulse enough. Because I can latch it. So in that case, I can do the OSR or OSF. For example, like in the same switch, I want to use the OSF. I'll show you something. Okay, what do? You go offline. You see first. You add, you click here. Okay, you add on run. Okay, what do? You put normally open. Okay, then you put counter. Go to counter. Then you add one CPU. Okay. Then for the counter, you just put a bottle count. For example, a new tag. I just give you a situation now to see how. you see, what I want to do is, so for this, right, I don't want to use the done. Okay, you see, listen, for the counter, right, when you are not using the done, you just want to use the accumulator only, the preset is not important. Preset is important if you're using the done only. So what I want to do is, okay, because I come here, after I fill up, then I move right, the sensor will off, correct or not? So when the sensor is off, I want to count 1. The movement sensor off, not the movement sensor on. Because it's already done, so I move it. Okay. So what I do, you add one more branch here. Okay. You click, you just add a branch. No. You click here. Just click here. Okay. You add a branch. Okay. You go in front of the branch. You add a OSF here. Under the B, OSF. Same. You put, okay, this one is same thing, right? Okay, so you put SW1 OSF, then storage bit SW1, you put SW1 underscore OSF. For storage bit, you just put SB now. SB. Yes, okay, great. Okay. For the output bit, okay. You put SW1 OSF output bit. OB. Yes. But in actual case, you can put, because this is the one I want to use here, right? Bottle counter or something you can put also. Or SW1 pulse. Okay, can also. Okay, you click here. You use this SW1 OSF. SW1 OSF OB. Yep. Okay. So means when switch 1 is on, I use the rising signal to on the pump. Then once the pump is filled and ready, the switch will off, right? I mean the bottle go right? The sensor off. So when sensor off, I create a falling pulse. Then I use the falling pulse to count the motor. So something like that.
How many
is already done? Because for this, even I can directly use the switch 1 also can. But I don't know whether it's already done or not. Okay? Because if I'm using switch 1, the moment I hit, I already count 1 already. So in the HMI, it will show 5 bottles. But actually, the 5th bottle is still filling. Maybe halfway fill stop means this one rejected. But in the HMI, I will show 5. It's actually only 4 bottles filled. So if I use the falling pulse, means it's already done and moved.
It's more accurate.
So it's just I just give example. So how
many function that we can
yes,
use.
means from the same switch, I can use the positive pulse and also the negative pulse, or a rising or falling.
Whether you want to monitor an inside or an outside.
Yes. Means very simple. When you want the signal, the moment the sensor on, you want the signal, or the moment sensor off, you want the signal.
So it's more accurate is the off the one. First you can check.
Yeah. Okay, we try and see. So you see, I'm not using the bottle gun, right? So the preset is actually not important when you are not using the gun.
Unless you want to execute another function, right?
Unless I want to use the gun and I want to do something, maybe what if I already reached 24 bottle? I on a packaging system or on the box or something lah. Then I need to put a preset. Then preset is 24. Then when I reach 24 bottle, I can use the counter done to do something. Okay, so what you do now, you on first, you on the switch. Okay, don't off because the pump already completed. Okay, no, it become 2 count. Okay, now the pump complete already. Okay, now only you off supposed to lah. Suppose just now it's supposed to be because halfway you stop already. Okay, now you do like example. Okay, again you on. The pump is feeding. Pump feeding done. Okay, so let's say the bottle is moving. Then the switch will off. Then okay, count 3 as well, right? Okay, that's how it looks.
Have to be creative lah.
Yeah, of course. If you're using the actual system, of course, you will get the correct number. And you need to be, how to say, you can put a pump as an interlock also. Okay. If suddenly the sensor was some issue, after feeding, so when the pump is still running, sensor is already off already,
So you
then I won't count.
You witness.
Yes, so I won't count as many. That's why if you see your system, got so many interlock.
Because interlock is basically to check the condition.
Yes. I mean the term interlock is used normally. I also put header plate. It's actually the condition.
If lah.
If all if
Interlock is like if.
okay. We take a break. Then after the break, we see some max function. Max function to understand the data types better. Okay. So this one, okay, you add a new routine, name it as mathematics. And you go offline, add another routine.
This one is
Max. Now what we do, maths is simple thing like go to maths. So in maths, you have CPT. CPT means it's like a compute. CPT means with data we use. CPT means it's like if you have a formula to calculate. Okay. And addition, subtract, divide, multiply is normal line. Okay, CPT means it's like a equation. Means I plus 2 data and minus 1 data, right? That one you can use in the CPT. Addition, like maths equation, if you want to do. If addition means it's only do the addition. Multiply means only do the multiply.
so the
CPT is like combination of addition, multiply, all that combined.
so the coins are computing.
Compute, yeah, they call it compute. Then you have advanced maths function, you know, like log, exponent, all that you have also.
Oh,
Yeah.
whatever related to mathematics.
It's not. So sometimes you need to do some calculation by PLC. Get some data, need to calculate, get some value, right? So you can use that one. Okay. So just first, initially, what we want to do is use the add, subtract, multiply, divide first. You put an addition. So addition very simple lah. Source A, source B, destination. Okay. What you do, you go offline first. Go for offline. Okay. So very simple. Whatever the value here, plus with the value with source B, the result will go to the destination. Okay. So we do a simple one. You just put in the source A, just put data 1, data B, actually data 1, data 2. Destination is the result. Okay. When you put data 1, the data type, you choose integer first. You just type. No, the data, just type integer. Okay, enough. Okay. Okay. Data 2 also say integer, and the result also, you put result 1. That one also integer. Yep. Good. You download, you test it out. Pending run edit, not download. Okay, download. Where's the pending run edit? Which one? Oh, this one. Okay, you just accept. Because now you do this and we go offline, right? Go to maps. Okay, so how to test with one? Because for now we don't have any source, right? Okay. Later when we have analogs, then we can become a source line, right? For now, what we do, we go to view, watch. Okay. Just key in any number and data 1 and data 2, you can see the result. Okay. Because currently we don't have a source. That's why we manually key in. Okay. Okay. You can key in some big number.
So can I use like the source A, like a pump 1, source B, other thing?
Yeah.
Like 1,
Oh no, Boolean cannot.
boolean cannot, it's only integer. Yeah.
It can be integers or real.
Oh,
Must be a value lah, because Boolean. Okay, I know the idea is, but let's say that Boolean you want to add pump 1 at the sensor 1. It means pump 1 normally open, pump 2 normally open, the output is what? One output. It's the same thing like for maths also, right? Because pump 1 1, pump 2 1 is equal to 1. So it's that's why Boolean we don't use in the numbers. Boolean we use as a context. Normally open, normally close, like that.
So how can I cross-reference this data?
Okay. Something like this.
Something like this, right? Example like result 1 got 20, result 2 got 20, and can we add here what kind of result? Right.
It can be anything.
Yeah.
Temperature or even
Wait.
okay, even just now where is the pulse function?
What function here?
Good. Where is the counter? Oh, you didn't use the counter, is it? Okay. Just now you use the counter, right? Okay. If you see, you go to your pulse function. You have the bottle count, right? The accumulator. I can use this accumulator to add also. Yes.
Oh, I need
The source A.
integers. Oh, okay.
So maybe bottle 1 accumulator and conveyor 2 punya bottle 2 accumulator, I can plus both. So make it into total production bottle, for example. I can do that way also. Okay. Okay. Now go to the max function. Okay. So it's the data, it can be depend from anywhere you get. It can be from the counter, from the timer. Okay. Remember yesterday. So like it is, remember yesterday when we do the timer. When we do the timer, right? This is the HMI timer, correct?
Yeah.
The HMI, this is the timer in, okay? Then, this is the TON, this is the timer preset accumulator. So let's say the name is the timer 1. Preset, okay, nothing lah first, right? What we do, I want to key in the HMI, the value must go here. Correct. So what we do, we use a move function, right? Source and destination. Source is the HMI timer in, go to the timer 1 preset, right? Correct? This is what yesterday we did. What happened to the value? So when I key in 10,000, so this one is a 10,000 and go to here 10,000, so my preset becomes 10,000, right? Okay. But when we want in seconds, can we do some setting here? Correct. That is do some scaling. Means when I key in 10, here I key in, internally it will convert into 10,000. Okay? But let's say you don't know how to do that setting. Okay, you don't know how to convert that settings. Okay, but you are good in programming. So what you can do, instead of using move, I use a multiply. Okay, so multiply, you have a source A, source B, and destination. Okay, so what you can do, the destination you put the timer 1 preset. Okay, the source B you put 1000.
Okay.
So what happened when I key in the HMI 10. So now I can key in the HMI 10. So when this memory is 10, multiply with 1000, the result will be 10,000. Because why? Because in my timer I accept in milliseconds 10,000. But in my HMI I want to key in second. But I don't know how to do setting in the HMI. So instead of using move function, I can do the multiply. Okay? And let's say I want to show the timer display, right? Because timer display means the accumulator, right? But it's 10,000. So in this one, what I do, I use a divide. Source A, source B. Let's say my source A is timer 1 accumulator, like move lah, right? Then divide 1000 and the value go to the HMI timer display. So your accumulator, or when you counting, I become 10,000, right? So 10,000 divide this one and HMI I show 10. So instead of using the move, I can use the multiply divide. Okay?
So can.
Yes. This is where you use the Parts function. But mostly in the HMI you can do the settings like the scaling setting. Yes. Just need to explore this. We can do it. Now we go to the watch again. Not enough for the Cynthia Portal 20. You key in 32,000, right? Below there, you key in like 10,000.
The result become negative because of it.
Okay, why negative? Because I did.
Because the whole is not to be 32K.
32K, right? Okay. Because we choose integer. Integer is negative 32,000 positive 52,000. So when it's above the value, the additional value will go add up in your negative number.
Go behind.
Yes. Go and add up to the negative number. So negative 32,000, add another maybe some number, so it becomes the 23,000. Okay. So what we learn from here, okay, in this case, so we need to use double integer. So this is where the data type place. Okay. So like this, then we need to use a double integer.
Because AB using the
Sign integers and sign double integer. AB don't have Onsite. They make it very simple, very simple. Even you can multi. Okay, close. Okay, if you can do something, you right click here, edit run comment. Okay, you can add a comment for this run, Okay, that is, you can put int integers equal symbol. Okay, put negative 32768 32768. Wow. You put a space 32767.
767.
Yes. Okay. That's all. Okay. So you can add comment on your run. So this comment is for your run. Sometimes your program or something like this. Okay. Okay. Now what I want you to try, I want you to try some multiply or divide a different data you put. Maybe that double integer. Then you test it out. Then you put real. Then you test it out. If you want to mix double integer plus the real, and result is double integer or result is real. How it works, you can try. Just play with that task. We'll be doing something. No, because they are semantic.
Oh, CMP. Many of this is one of the only got in that maybe I think that
Yeah, I understand.
so
Yeah. Huh? Yeah, but sometimes I do, I didn't keep most of the Yeah. Yeah.
CPT usually how do we use?
It's like a formula. CPT, if you open CPT, you will use a destination, right? Then here's the expression. The destination can be like, okay, you create, but for this you need to create the tag first. Because at least you put a name, you can rightly create new, right? But CPT cannot. So you put result value, like for example. Then here you can put an expression. But you create all the data first, or you want to use back the same data you are using. Data 1, data 2, right? So, but the destination must be new one, right? Data 1 plus data 2 divide data 3 multiply 5,000, for example, a constant number, like a formula. That's called CPT compute.
So destination we can create a new.
Destination is new one. This one all you can, for now you can use back. But in the actual system, it depends on from where you take. So later we will be using CPT only for our analog scaling. But later for analog scaling we will be using CPT. Because if you want to do the one by one, right, man, I mean, multiply and divide will be difficult due to use too many calculations. So it's like combine 3 calculations in one. If no, this one I need to add first.
The same thing.
One calculation. That's not what you do. I add first, then I need to multiply first, then I take this result, divide. Then only I will get this one. This one is the formula. That's one. Inside here, I already got some of the starter.
Okay.
4.5, 5.5, 5.6. Then I'm copying the 80 all together. Very 16 GB something.
16 GB.
Because got 3 software. TR Portal, Professional, WinCC, and Safety all together.
All together. Include safety also.
I installed the Safety all together. Then additional is the WinCC Unified. It's the SCADA. Okay. Then what else? Simulation.
Oh yeah.
Simulation software. Yeah. Later you can see even licensing in easiest one. Licensing. And that will be very hard to get license. Okay, you try the CPT and see how it works.
Kalau you mau tambah-tambah, saya tolak ini boleh kayak gitu.
Okay.
No, I want to accept that he told me the operas, missing operas or the
Okay. Okay, you click where missing operator or argument. Did you?
here.
Here.
Yeah.
Double click here. This one what? You got the question mark in front.
Missionary.
The question, okay. Then just click it. Okay. Alright.
So the what I want to join, let's say we need the what I need bracket, right?
Okay, what do you want to do? This result you divide with what?
Multiply.
Can multiply or divide and then
Multiply, then need bracket.
no. Depend. After that, what do you
Let's
want to do?
say my I want to multiply with this number.
Okay. Just double click. No, here. Okay.
Plus
What I say?
Okay, this thing how to change is can change.
Yeah.
But from here is B3, then here is B2.
No, that one is because that is the program inside your one. Download first.
Go on.
Okay.
Mm-hmm.
What is okay? Because now your program inside your PLC is literally as one. Okay. But if you click here, yeah, it shows that there is one, right? If you close this. Close first.
This one.
Yeah, okay. Okay, now you open now. You close the back plane and try to open the new. Yeah. Okay, because you need to refresh it. You open. Literally doesn't work.
B3. But then here the title is day 3, but then I see with day 4, why comes out B3?
Oh, okay, one. Close.
Close everything.
Yep. You go to file, save as. Okay, the project name is this one. Your controller name is day 3. Okay, close. You go offline. The controller name you can change.
I go offline.
Yeah. Right click the controller. Properties. Controller name.
This is nothing.
It's a controller name. It's like your machine name or something. It's not important.
But let's say every time this one is supposed to follow the project's file.
Yeah, when you create new, of course, it will show that a new file, new name. But you see, I think what you did maybe you open the SLS project, you save as. So when you save as, the file name become new. The controller name is different.
Still remain the one.
Yeah, old one.
See.
If you create a new project, then you give a controller name. When you save as, the save as actually is give you suggestion only. Use this name. You can use any name also, okay?
So let's say I'm using the project, I save as the new file,
And the controller name you change.
or I need to change it. Otherwise, it will follow back.
Follow back the old name.
Okay.
Because one is a controller name, this one is a project name.
So this one is not necessary every time you save the project, this one will be changed. Right?
Yeah. It's just input PLC PLC one. Or the CPU. Any name lah.
So usually, let's say I create new projects, I will sign all the name, then only I connect to the path.
Yeah. So the path will be always show your old one.
The same path is this one.
Yeah, now you can.
Okay. Or the I supposed to using here connects or I use the proactive connect.
Proactive and this one is the same thing.
Same thing.
Yeah.
Only proactive is
No, proactive is it will open up whatever we list down in our other stream class. That's all.
It's the same thing.
It's the same thing only.
but this one still remain day 3 even though
Because you haven't downloaded yet. But
I see.
you change the name, but you haven't downloaded yet.
Yeah. Outside this one.
Yes.
So this one still remain today.
Yes, same name.
Back.
So what you do, you off this one, you close the cable back.
It takes some time.
You like refresh lah. Okay, good. Any question? Good, ah? Now what we do? We go offline. We add annual card. So I add annual card here. Okay, because only one input, one output. For you, you can simulate the numbers. Okay. Yeah. You also can configure the same thing. And you can repeat the module. I will show you. Okay. Because if you configure, then you download whatever to show error, right? Right. Okay. There's a function called inhibit. Inhibit. Means in your project you have, but physically you don't need the device.
Okay.
So later I'll show you.
There's
Okay.
an option inside the
Software.
inside the module.
Yes. Okay. So what you do? So you remove this one, then you add this two. It's already connected. Okay. Okay. This one is derail. Okay. So this one is the input, this one is out. Okay. Now this one error because it's not remove lah, right? Okay, you clear the error using the key. Run the keyboard. So the I/O will be blinking lah because there's a two new I/O. Okay. Now we can use the same project lah. Okay. To add these two modules. Use the same project to add this. You also can add. Yes.
No issue, right?
No issue. But before download, I need to do one setting. I have 4i. What one for I? Yes. Okay. Double click. Click. Okay. Input is an analog input. Okay. Analog input. Can you go to config connection? Connection here. Yes. This is what I mean. The inhibit the module.
What does it mean? It means
Okay. Inhibit means in the project you have, physically it won't scan my CPU won't search for the device. Okay, so for you, you can use this inhibit module. This one later I show you one. You add first. What's it?
Oh, yeah, I mean, I will download personal file.
I know for of course. UF.
The F is stand for what? Out, O is output. F is what? Because we
F is
use
because IF OF right? I think F is for analog. Yeah.
But digital usually they use Q and V.
Yeah. Yes.
What is it? Basically the same Q. I O, you know that is input and
Input output lah. B is Q means is a source or sink.
Ah, yeah.
Yeah. B is just a source.
Source. Yeah. For
F.
analog is standard like F.
Then that F. You see all the analog got F. They say is F represent is a function. F means function.
Function.
IF means input function. That's what they say.
But this one is the analog for voltage, right?
No. The one we don't discuss it at first.
Okay.
At first. Okay. First. Okay. So we already added, right? So for you, right, it will show like this. Like circle H. Like this. So it means it's inhibit. Okay. Because why I need to add, because let's say you can ask me, okay if the module is not there, why I still need to add? Right? Once I add, then only I will get the controller tag go up. Then only I can get the controller tag. The local go down, local 4 and 5. So then only I can do the layers, to ready my program first lah.
Offline programming.
Yes. So I create the logic first, everything. So later when the module I have, then I connect the actual module, then I remove the inhibit and download.
Okay.
Means I ready the program first.
Okay.
Okay, prepare the program. Okay. Now we can go to the analog. Go to the analog input. Okay. So go to properties. Okay. Go to configuration. No, you go to general, go to connection first. Okay, because the general you know, right? You go back. Okay, sorry. The general you know, right? That is the module, the series, all these we can change, right? Okay. Go to connection. Okay. So inhibit, the RPI means requested packet interval, means is the time I take to scan the data to send to my CPU. So means it's 80 milliseconds. Okay, it's in MS. Okay.
But this one is standard.
For card is standard lah, but if you want to increase, decrease, is up to you. Okay. Inhibit module just now I told you, right? Okay. Okay, major fault on controller if connection failed. Okay, you know if I remove this, if the connection is failed, it would create a fault. Okay, but for this module it won't work. Because even I do for all these I uncheck this one. If I remove one, right? If I remove one, what happened? You know, still go to fault because the last one not detected. But if the card is faulty, the connector is still there, but the card is faulty. Then if I enable this, it won't show any error.
For a particular card.
For particular card. Okay. So that is this one. Go to configuration. I have 4 channel. Okay. You need to enable first. Okay, then only I can change the input range.
Yeah.
Okay, how it goes. So this is my CPU. This is my analog input card, right? Let's say I connect a transmitter. This transmitter connect to a sensor, for example. So the transmitter job is, let's say this is a negative 50 to positive 100 Celsius. Okay. The transmitter job is to convert this data into a analog value, right? The common one we use 0 to 10 volt or 4 to 20 milliamp. So that's common. Okay. My analog job is convert this number into a digital number. Okay. If Siemens or other brand is a fixed number, the number is fixed, right? But Allen Bradley, can you see the format? You have a raw, you have an engineering unit, scale for VLD or percentage. 4 types of data you can get. Okay, so we see what is the data. So if it is a raw value, this is the 0 to 10 volt. Or 4 to 20 milliamp.
Itu PC jadi isu. Jadi apa? Yang nak configuration.
Tak ada orang berani. Tak ada orang mau naik tu.
Betul. Nah, dia kena ada satu
Dia ada fasilitas teman dia buat.
yang boleh buat dengan
Cuma tak ada orang mau naik. Saya tak faham.
at least kan sebulan sekali mungkin lah dengan
Betul lah.
bukan semua hari-hari ni pun.
Okay, so we have a raw, then engineering unit, then we have a scale for PID, then a percentage, right? So percentage very straightforward. Percentage is 0 to 100, right? Right. So you add like 2 more number, right? Okay, so this is the number you get in your PLC. Same for this also. Okay, engineering unit follow this number. It's 0, 0, 10,000, and another 3 number. Here is a 4, so another 3 0, 20, another 3 0.
Oh.
So it's engineering unit. Okay. PID is fixed 0 to 16384. Because why if I'm using PID means I need to use that for PID block. So there's a block for PID. Okay, so for that PID block, you can choose this. Then directly this tag directly get used for the PID block. Normally we don't use this much lah. You can use percentage, engineering unit or raw. Raw value is a big, the range is very big. That is negative 30,100 something. Okay, negative is 29,800 something. Positive 29,000. Yeah, it's the same. Something like this, the range. So this is the range you get in your CPU. Mostly PLC, other PLC only have one set only. If this is the range, this is the value. If in percentage, in percentage. But element you choose. But different card, different style lah. If you choose other card, sometimes will be only engineering unit. Or sometimes directly here itself you can do the conversion. Straight to convert to the temperature.
These ones, the data format us as a user, it doesn't matter, right?
It does sometimes.
It's matter because why? Because you want to convert these data into your temperature.
I thought the data is supposed to come from the sensor, then scale to use.
Yes.
Yeah. So
But what you get in the CPU? Do I get the temperature value or this value?
because after the digital converter,
After the digital converter, you convert this data into these numbers, not your temperature.
no, I means what is different between raw and
It depends on which one you want to use. They give you like few
And also it depends on the what type of temperature sensor you're using.
No, this one doesn't matter. It depends on what I receive.
yeah. That one is backends, all the backend.
Yeah, that one doesn't matter what I get. Because PLC only get this data.
Because to us as a technical personnel, what I concern is the
Okay,
zero
as a
to
technical person, okay, correct. Because whether I get this data or this data or not.
yeah, until the AI then
Until here lah. Okay, from here to here, of course, the PLC guys job lah.
it's
Do
not
the scaling because you know why. Once I get this number, let's say that I choose engineering unit. Once I get this number, let's say it's a 0 to 10 volt, and I choose, then the programmer job is to convert my AI value, which is 0 to 10,000, convert to negative 50 to 100 degree temperature. So the programmer need to do this calculation. The programmer job is because I get 0 to 10,000.
okay.
So the programmer need to convert back to the engineering unit to show it by HMI to do some programming. So the programmer will do this one. So this one is fixed. This one is fixed based on your sensor. This one is based on your what you choose here.
So they just convert from the analog range, then associate with the digital range, right?
Yes.
If they say here, then it will refer back to digital range.
Okay.
So okay, I see.
So what we do? This one we use the formula y equal to mx plus c. Standard formula for the linear scaling. Okay. The problem here is in ladder logic, you don't have a scale block. Normally, most of the PLC they have a scale block. Means You just need to key in all the minimum, maximum value, put the input there, it can calculate for you. But in alphabetic ladder, you don't have. Only in function block diagram, you have the block.
So they have.
Mostly other PLC they have in ladder logic. Okay. So what happened in alphabetic, if you want to convert, you do your own calculation.
Every single point.
Yes. But there's many ways to do it. I will teach you. Okay. So if this one, if I want to do, I need to do 3 calculations. The first calculation is to find the M. M is the gradient, right? So Y maximum. Y. This one after what is the after the gradient. Then X maximum minus X minimum. You get the M value, the gradient. Okay. Number 2 is to get the C. C is the they call offset. So Y minimum minus M X minimum. Then this is the third condition. So you already get the M, you already get the C. X is your analog input. So when the analog input increases, it will multiply and plus with this value, you will get the temperature. That's our normal linear equation. So this one, right, you can use the CPT as now we use. If no, if I do manual calculation, I need to subtract first, then another subtract, then this one is for divide. Then I need to multiply here, then need to subtract 5 calculation only. Then this one need to add first, multiply first, 6, then plus. So need to do 7 calculations. Okay, if normal calculation, if you don't have CPT. Don't have CPT, if you do 7 max function.
Because if I can use this one,
If CPT can use this 3 only.
then 3 only.
3 only enough to get the Y. So first need to find the M, second need to find the C, X is your analog input. So can get it. Or even you can replace this thing with the M, you can replace this thing with the C, make it into one whole big CPT also okay. But it will be very long lah.
Okay.
But still can do.
So you just now mentioned can Siemens be using which one? Raw or engineering unit?
Yeah, we use
No, normally they call as a raw number, raw value lah.
Raw now.
Raw value normally. Okay. So
So
mostly PLCs only have 1 raw values. Here they have like 4 raw value, but they give a different data. One is raw, one is the engineering. Because raw means big numbers. So engineering unit, okay, we make it into engineering unit. PID, then percentage 0.1%. Some other cards you don't have, and even in the elementary, before let's say some other cards you don't have this one.
I see.
Even if you won't have anything from here. That is because they will tell you what you know. You can directly convert to temperature only. You don't need to do this calculation. In control Logix card.
on this card only, on this model only.
So some card you don't have this type of just directly can convert.
But the value on others brand, right, using that negative.
No. It's, the value won't be same with the other PLC. Different value. If Siemens is a 0 to 20, negative 27,000 here. Negative 27,000 to if negative 10 to 10 volt lah. If 0 to 10 volt, it's a 0 to 27,000. This number is for Siemens.
So the maximum is negative is 7,648 to
Positive
27.
648. If Omron, some is 0 to 4,000, some more, depend on the models. Some 0 to 4,000, some is 0 to 12,000, some is 0 to 16,000.
Depend on the brand.
Yes, depend on the brand, depend on the modules. Only Siemens, the 300, 400, 1000, 2005, all same. All use this number only.
But they have their own conversion already, right?
What's that?
They have their own conversion
All, so they have the blocks for you.
So
You can just use.
kepala buat benda ni.
What's that?
Saya punya kepala buat benda ni lah.
Yes, no need to, we don't need to do calculation like this.
Only this model, for this card only.
Not only for this card.
Some
Elementally, in ladder, they don't have a scaling function. So you need to do this one.
but that control
But-
logic have.
In control logics also, same. In ladder, don't have the block. Okay, but in control logic, some of the card, in the card itself, we can do the scaling.
Like this lah.
Like something like this. So, but you can straight away choose what number to convert. So, I mean, straight away can do this one.
Okay.
So, means here they only give you the number only. But in that electrically, in control logics, the analog card, they will have what they call another value called engineering. So, from the raw number, you want to convert to what number? They will give you
They done at the cut level.
the card level, the stick version.
Your programming level.
Yes.
Okay.
So don't need to do additional programming. So straight away you will get a temperature.
But why level is the
Oh, this is all bigger. Yes.
Not older model, maybe compact.
Okay.
Compact. Because maybe compact you don't use more analogs. So that's why they have these functions. Maybe control logics you go more analogs. Maybe 20, 30 analogs. So you don't need to do so many calculations. So the card level they have that function.
Boleh ke?
Okay. Okay.
just a different way now, right?
Just a different. The thing is, we need to understand how it works. That's the important thing. How it works. Then after that, we can know where to use.
The fundamental is the same, only maybe it be used in different way.
Yeah. That's why I say all PLC same. All PLC will have something like this. Only elementary, I mean, for this model, compact logic, they give you 4 values to choose. And mostly they have only one value fixed. Okay, good. Okay. You go for a break, then after the break, we come and connect some analog. For initial, for first, we connect this one. This is an injector, signal injector.
Tak proses meter lah.
Like a process meter lah. I have the process meter. But this one got the battery after you use 3-4 times the battery got.
Okay.
Measurement okay, but if you want to inject
Okay, 20 something.
420 right, the battery after 3 or 4 training, so that's why I buy like this. Fluke. So I buy like this because I supply 24 volt, so you can just use only. No battery this one.
Okay.
Actually you can buy one also. 100 ringgit something.
Macam media kan ya?
Yes.
You can set to 0 to 10 volt like that as well.
Voltage also can, milliamp also can.
DC.
Yes. For your, instead of using this one just to make sure, but won't be accurate. Compared to flow lah. Let's say here you get 10 volt. You put 10, but you measure is sometimes it's 10.01 or 10.02.
Oh, plus minus 1%.
That's one. For this one, for your system, you can use to just to check whether the value is there or not. That's all.
Just a test.
Just to test values there. If you want to test with the accurate calibration, must use
Process meter.
So we can use this one. Once you understand this, then we can use. I have a temperature controller. So this one measure the thermocouple value, can convert into hot value. So we can use this to do some problem. So because in with the analog, right, we can learn. Of course, we can understand the calculation just now we do. So we can learn the max function, the data type, everything. We can learn how to use the function block diagram. We can learn the add-on instruction function, the same analog things, add-on instruction function, and we can learn the structured text programming. So all these we can learn with analog. Easier to understand.
So this display also have to set. Or just
No, it's already directly convert to for training.
They are already set up.
Okay. So we go for a break and continue.
So today more on analog.
Yes, more on analog, numbers, data type.
All right. Kali. Ya. Satu kali.
One So you want to use voltage first. This one, this two is to power up the module. 24 and 0 lah, ground. Okay, we power up. So you can connect to here 24 and 0. And this one, ground is the 0 volt, AVO is the positive lah. So channel 0 plus is the AVO, channel 0 negative is the ground. So you connect to the channel 0 first.
So this one doesn't need any channel 24.
No need. For input no need. Only for the output we need. Yes. So the input no need. Same like for the digital inputs. Oh, yours. Okay. Now go for this part. Enable the first one enough. The rest going. Change the input range to the 0 to 10. Yeah, okay. Yes. Okay, you download first. Okay, now what we do? Go to control track. Now it's a raw proportional, right? Okay. Go to monitor tab. Monitor. Okay. You local 2 off. You go up. Go up, go up. Local 2 you close. Okay, sorry. So your counter also you close. Okay. You go down. So your local 3, right? So local 3 is an input, correct? Local 3I. Okay. Where is it? Okay. Can you see channel 0 data? So this is not only local. This is where I get the value. Okay. So can you see channel 0 data is an integer. Okay. Like I said, this number, right? All the data is must be an integer.
Okay.
Okay, so now you choose raw or proportional, right? The range will be like this. Okay, so it's supposed to take around 29800 lah. Okay, so you go to 5 volt first. When you go to 5 volt, you will get 0.
Center point.
Center point, not 0. Because negative to positive, right? Okay, supposed to get 0, but you get 97 lah. That's the sum of offsets. Okay. So we change this one and see what you get. So when you're online, you can go and change to engineering unit. Right click here. Properties. Change to engineering unit. Okay. Okay. Wait on. You must see the message. Okay. Alright. You see, engineering unit 5 volt is 5,000. 10 volt is 10,000. Okay. Say you try the PID. Okay, wait, it shows that I apply this one here, okay, so it will go and apply to actual hardware. So any mistakes it will affect your program also lah. Okay, so that's what the message show. Okay, okay, yes, yes. Get 8,000 something out of this. Okay, and percentage juga, percentage is the same thing. Try it. Same 5,000, right? So I already get the value. So I get the digital number lah. So let's say which one you want to use. Say the percentage of engineering is the same number, right? Let's say we use engineering. So it's common lah. Okay. So change back to engineering. Okay. Alright, now we do a program test. Okay, you go offline. Okay. You add one routine. You put scaling. Okay, so you also can do now. But the later value manually you key in. Like yes. Okay, also.
So I can see.
Okay. So you need to create a new logic, new as well, or you just change your project. It's L35.
L35.
So you change your controller to L35, then you update the I/O configuration. Because last time I have two set of input output, but the one set I already set.
But why can an honestly they take this one? Whether we can instrument.
Did you put two?
Tutu is that IP.
Which IP two?
This one.
You already have? Yes. You are asking?
We already have many, but there's no. Oh, I'm already.
Configure that. Which one you want to use? Okay. Oh, use the Ethernet IP. Yes. Okay, never mind. You don't use the Ethernet IP. You use the Ethernet.
What is the difference? Internet IP.
Ethernet IP is scanned using your port. But just now you see your port is a different IP than it's not. It's not 192.168.2.
So internet device.
Use Ethernet device. Because Ethernet device, you just directly key in the IP address. Ethernet IP driver, it means you're using your laptop port to scan. So just now you see your laptop port, the IP address is different. So what you need to do, you need to open a command. You need to clear command prompt. You need to clear the IP of your laptop port first. You need to clear because so many times I'm using the port, right? So for this training I fixed one IP. So the IP is always there. So you need to clear the IP, then need to create it. Then you can scan. So just now with the IP, it doesn't start at 192. It shows 169.254 something.
Yeah.
So that's fine. Cannot complete. Okay.
This mapping station, I don't do anything, right?
Oh, you need to key in the IP.
Get IP.
Yes. One. Not IP. What is that? Okay. So what we do? Because let's say I want to do a calculation. So now it's my analog input is 0 to 10,000, right? Because we choose engineering unit. Okay. I want to convert to -50 to 100 degree. Okay, for example, so I need to do this calculation, right? Okay. So for now, what we do, you go to controller tag, First you go down, go all the way down. The local 3I can off, close. You put analog input channel 0. Then you alias to your input. CH0 yeah. Okay. Then you alias to your local 3 I channel 0 data. Yes. No. Must be an integer. Correct or not? Your local channel 0 data must be a integer. Because because just now where I get the value. You go to local 3, what? This is where I get the data, right? You highlight here. You highlight here. Okay, this is where I just now get the data. Correct? So I must choose that. It's not a boolean. Only boolean we go to data, then 0, 1, 2, 3. We need to go and search for booleans. Okay? For analog, it's just a channel 0 data.
So take this back, multiply it or divide by it, the value is something like that.
Yeah, something like
Yeah, true, right?
that.
Oh.
So, yes, channel 0 data. Okay. So this is where just now I get the analog value, right? So I alias to my tag.
Okay.
Same like what we do for the lamp switches.
Oh,
Correct.
okay.
Don't confuse. It's by okay. Which one you confused now? I see you look confused.
No, now I.
Okay, what I'm doing here is same like what we do for the equal to. That's all. Because why? Later when I do calculation something, I can use this tagging one. That's all. Okay. So I already have this tag. Okay. So I want to create some tag like this. Ymax, Xmax, all this manually that. Okay. Okay. You go here. You put AI 0 underscore. Okay, this one is for the M. M is the gradient, right?
Okay.
Or the we can call as a rate lah. Okay, if you understand the M, you leave it M. Okay, and then but you see M do you want to use double integer or real?
Integer, small one. Oh, it's a right.
So it's a small number because Ymax is what 100 and divide X max is 1000. That doesn't right. So integer is definitely, but I will get in points. Correct?
Okay.
Because 100 divide 10,000, you will get 0.01 something. So I must use real.
Real points.
Yes. So choose real here. Type R real. Okay, got it. Then your Ymax, Ymin, Xmax, Xmin. Same. You put AI 0, okay. Ymax, Ymin, Xmax, Xmin. This one, it can be integer or real. It's up to you lah. Because this one is you manually key in. Okay. Ymax you put. Ymax. Ymax, Ymin, Xmax, Xmin.
On.
On. I want to put on. Later I will show you without this actually. Okay. Then X max. Right? Then all choose real. Can type directly, can type there. Literally, you can directly type. Yes. Okay. Now, so this one Y max, YB, VF ready, MVF ready, okay, so F ready, C is offset. So we put AI 0 offset. Offset, yeah. Real also. Okay, good. And last one is your Y. Y is the temperature, your result. Okay, so you put one in temperature. You can put AI 0, but normally you don't need direct temperature enough.
So offset is a C, right?
Okay. So now I want to use this, all these, and I do the compute using this. Okay. So you do it then, go to scaling. Okay. So you take the CPT, first one. Okay. So first one you do this one. M is what? Your destination. The AI 0M. Yeah. Okay. Then you put Y max minus Y minimum, X max minus. Open bracket. Something wrong. Open bracket for that. For the first.
Sure.
Yeah, double click. Yes.
This one also need
Yes.
bracket.
Yes. Okay. Still got error. Why?
From here, how you know? Oh, okay.
Oh, the slash is wrong. Not this slash. It's another slash. Yes. No E.
Okay.
Then you do for the offset, and finally you do this one. You can get the value. Next one is the offset is equal to y minimum minus the m multiplied this. So M is the M, right? So you put bracket, open bracket, open bracket, because M multiply X. M is the one. X is your analog input. Okay. Alright. Okay, so this is the calculation. Yeah. Okay. But there's many ways to do calculation. This is a standard linear scaling. But there's many ways to get a linear scaling. Okay. Now, download this. Okay. So you see temperature, no temperature, right? No temperature value because you know why? Because there's no value in the Y max, Y min, X max, X min. Okay. So for now, we go to view. Watch. You key in the Y max, Y max, Y min, X max, X min. All these values. So what is your temperature now? Why you post view? Go to view, watch, make it smaller. Actually, no, actually you okay, make it smaller. I just need this much only. Yes. Okay. Okay. So you see the temperature you get 25.25 Alright. Because you put how many? 5 volt, right? So 5 volt means around here, right? So you get around 25. Because it's a 100 to negative 50. You go to 10 volt. Then your temperature increase go to 100 degree. Okay. So this is how you get the data. Okay. Okay. For now, you see, for Y max, Y min, all this, right? I make it into a tag and I manually key in here. Okay. But normally, what we can do, we can directly use the numbers here. Instead of using AO, Y max, Y min, all this, right? I can directly use the numbers. Because I already know what is the numbers. So directly can use also. Yes, use the same formula, but this one directly I can do.
So the destination I put that YM
This one same like M,
uh-huh.
this one C. So this one you key in according to this. And this one M, of course lah, must M. This one was 0 lah. Right. Directly you do this one. Then for this one, same. For this one, you take these two data lah and use here. Because this one is the M you already find out already. C you already find out. X is your analog. You can do that way also. Okay. Or you can use a function block diagram, not ladder logic. Because inside function block diagram, they already have a block for you, scaling block. Yes. You just need to key in analog input, then you give one output, you key in all the Y max, Y minimum, you can get the figure. Okay, we try that. Okay, go offline. At the same time, we learn what is FPD then.
So usually people will do this kind of formula or directly.
It depends. Later I show you another way. The one I show you. There's many ways. First is, if you ask me, later I show you one. I use that way. Yeah, go fine. Okay, you right click. And use one, sir. You already have this one as well. FBD here. When you create this one, how do you see? Okay. This is a function block. When you create this one, is it wrongly create or you create?
I create.
Is the dot? Okay, okay. Never mind. You right click, delete first. So I want to show you. You delete first, right click, delete. Yes. Okay. So what you do, you right click main, new routine. You put here FBD, function block diagram. No. The type here. Function block diagram. Name, you can put scaling FBD, the name. Scaling FBD. Okay. Okay. You add here. You add one run, then you add here. Under here, go to process. Can you see SCL? Yes. This is the scaling block. The scale block is available in FBD only. Bring it to here. Okay. We open here, inside this one, yep. We will make it bigger. This one. Yeah. So they have a meaning lah. Input is the analog signal instruction. Okay. Then in raw max means the maximum value attained by the input or to the instruction means your X max lah. Input raw minimum means the minimum value attained by the input. So your X minimum. Maximum scale value, this is your EU max is your Y. EU min is your Y minimum. Same thing. Actually inside here also there's the same thing that is. But they have some additional functions. That is, if the input is above your maximum value, give you alarms, all that you can.
Okay.
Okay.
Yeah, I just want to ask one thing.
Yes.
Okay. Why is the going the top one?
Yes, this one is one.
Okay.
X.
X. C is going there.
No, actually
C is
C
the raw
is this
data.
one. C is this one. Your offset.
My offset.
Yeah, offset is a C.
Oh, so what? For the raw data, it's not inside there.
Raw data, no, not inside here.
Not inside there. Oh yeah, I just confused that one.
So the raw data is the one you will get from the x-axis lah. Actually, x-axis is your raw data.
X-axis is my raw data.
Your raw data.
Okay.
So that's why you put raw.
Okay.
You remember just now I told you, right? Normally this one, okay, of course we have a raw engineering. Normally they call raw. So that's what they call raw. These numbers all they call raw value. Because this is your what they call your sensor value lah. The sensor you mean what sensor you are using. Okay. Okay, what do? You enable all the input max and the EDU max minimum all this. Because this one mean VI mix is a visible. Visible lah. Okay. It's okay. So I get this. Okay. Now what I do, you click here. Input reference. Drag and put it on here. Okay. Then from here to here you can connect. Yes. Okay. Now this one is your AI channel 0. Your analog input channel 0. Okay. Yes. Okay. Same. For all these is the same. You take one. This one, I can use the tag I created, right? Minimum, maximum, or I can directly put the number here also can. So in raw max is what? 10,000. Can you put 10,000? All the minimum maximum. For the output, you create a new tag. Output create new tag. Because you can use the same tag. Because I already used output in the another place, right? So you put a new name like maybe temperature 2. You don't know anything? You get the value. So no need to key in lah. The X max, X min, all no need to key in. Because the value is already there. Means you can use your just now the calculation on this method also if you.
So we put the sensor, is any input lah.
What's it?
Then we put the temperature sensor,
Same thing.
same thing.
Same thing we can do.
So now we treat this one as the
Temperature lah.
Alright, now it is my candidate.
Yes.
We
You can use that also. I connected. See, I need to okay, this one. Okay. This one pin number 15 and 16. Okay, it's a 4 to 20 milliamp. It's a 4 to 20 milliamp. Okay. Pin number 15 is positive, pin number 16 is the negative. Okay. So you can use the channel 1. Okay. Can you see? I think maybe the last week. Sorry. Say the channel 1 plus is the 15. Pin number 15. Okay.
Okay.
The negative, right, go to the negative. Okay. Since it's a milliamp, I need to take the negative, loop to the input written. These two need to be looped. Then the positive is here. Then only my card can read a milliamp. If only I connect plus and minus, it will be voltage. For milliamp is all these three need to connect. The input written need to connect back to the negative. Okay? Can? Pin number 15 come up. And so if 15 is 16, then the channel written I need to connect back to. I think the cable is already connected.
So then we just tambah lagi satu cable kat sini.
Yes, negative. Okay.
so using current one, you need to look this one.
What's it?
4 to 20 milliamp.
Only for milliamp.
Because usually using current one is very small.
Yeah. Yeah.
Can you use one?
No, it's a 230.
This one, which is
I connect it. I connect the 230. Because this is a thermocouple. Yes. So if you use thermocouple, actually you can use thermocouple module. Yes. If you're using thermocouple input, then you don't need this one. Direct calculated thermocouple IF thermocouple. Okay. So they have 15. You take the ground. So for that also you do something. Okay, now what you see okay, wait, before that, okay, you put analog input channel 1. Then alias. Channel 1 data, yes. Okay, now you go here. Now go to the configuration. Yes, you double click this one because you need to enable the channel 1 button. Okay. Already enable. Enable channel 1, enable first. Yes. So it's a 420 EM. So use engineering unit. Yes. So later when for your calculation you must use this. Okay. So I will put it here. So for engineering unit, so now it's AI1, right? Correct. So it's the data is a 0 to 100 degree. I already set the controller to read 0 to 100 degree and convert into 420 degree. Okay, so you will get 4,000 to 20,000, convert to 0 to 100 degree. Okay, so this is one. So the 0 I click on. There's no 0. Okay, now it's up to you whether you want to use this one or you want to use the SCL function in the FPD. Okay, do the calculation, you see, you can get it. Correct, ready?
Correct.
Okay. Then you power up this. What's this? So it's the HMI line. Now 28. That's why you can use like those.
Can I share the same routine?
Yeah, obviously.
Scaling
Yeah,
can run with stuff.
yeah. If you're using the FBD, so you need to add another SCL lah.
Okay.
If you're using the normal ladder calculation, you need to do another set of calculation.
If let's say function block,
The FBD are another SCL block.
another SCL block. Yes. I just create the input and then the raw data and
Then for the output, you put temperature 2 lah, new one. Oh no, maybe temperature 3.
why the value is going very high?
Which value? Okay. Your input raw is what? X max. Right. Your input raw, input minimum, and EU max all wrong. Raw is X axis. The horizontal line. So 4,000 to that one is 20,000. Put the opposite.
SCL is scaling, right?
Yes.
Scaling. So in the controller tag, right, whatever lies with the physical input, we consider is digital. because we really put in his integer again.
What's it?
Even it's a analog card. Physically we receive analog signal. But plans to be PLCs, this one, the studio, we still put in as an integer.
Yeah, of course.
Of course. Because the moment you receive is a demo, but as the backend you read is digital signal.
Yes. Yeah.
So in the system itself, we recognize the digital. That's why we put integer.
Yes. Yes.
Okay. So which means that everything that is lies with the physical input, we need to put either or is digital, other booleans, integer, double integer.
Boolean and integer.
Yeah. So all is digital. So,
Yes, but then you don't confuse with the numbers. Digital, of course, is 1 or 0 lah.
Covers from 1 to 0.
Yes.
All those we receive one in this form, they have to form
Still, when you go to PLC, it becomes like 1 0 0 0 1
call
1.
back to the digital.
Yes.
Whereas we use real is not the physical input.
I know.
Correct. The real is used for not physical input.
Yes, inside the PLC. Real.
But using function block is much easier.
Yeah. Okay, good. Okay. Want to go for a break? We can go for a break. Then we can learn the add-on instruction.
The Germany guys still working at Singapore. Or going back again.
No, it's still in Singapore, but now it's time takeover.
Oh, so past the distance. Also quite old, right?
Yeah, he also. I think 60.
Oh,
67.
last time he also train.
No,
He never do train.
you know, he knows the project.
Oh,
He don't do trains. He do only Siemens.
Oh, he purely seen now.
He only played Siemens. Yeah.
So very focused on cinema.
Sometimes last time if I was on any Siemens product, then he buy from Germany. Because every 3 weeks once he go to Germany.
In terms of product, more comprehensive one, I think is cinema. Everything.
Yeah. Siemens have so many products. They have another controllers called IoT controller. But I
Not many people using it.
never touch it.
Not many people using it.
But they have. But I don't have the opportunity to play with that yet.
Unless the company using some companies.
Unless I really want to use that, then I need to see the people source for it. IoT 2040 the model. Okay. So you already see how to do scaling and FBD. Yeah? What now I want to do? I want to do same calculation.
But function block, right? Beside doing the skills,
You can do normal
that else is useful.
no, you can do normal programming there also. Start stop auto timer got so many
But then people still prefer using
prefer like that. If you see someone using FBD, then means it's maybe they are good in FBD or they don't want like other people go and
Kacau.
kacau.
Because not many people
Not many people know FBD. Many people know ladder.
straightforward.
Straightforward ladder also easy to understand, easy to learn. So for the training mostly I use ladder to teach them.
But in Malaysia, not many people using IBD. A lot.
Sometimes big machines lah, especially like Siemens and maybe
You mentioned this Germany people like to use IBD.
I'm not sure. Like what I mean is last time I told you one guy come right, the university level teach FBD. I'm not sure why. Because FBD is something similar to your AND gate, OR gate, electrical you have that right, so similar to that. So maybe because of that they teach that. But in Malaysia, they teach ladder. Mostly ladder. Basic. Because they cannot teach
Too many.
too many, and also one is of course if you teach also the students will understand. Because they don't have industrial exposure.
Yeah.
Another thing, because last time I have a participant from lecturers from WinCC. Okay. So of course at 10 lecturers attend the training.
Oh, lecturer in the training.
10 lecturers attend the training. Only 3 lecturers they teach PLC. The other 7 will just join only. They just join because of if you are engineer resistant to some BEM or something, you need to have like the CPD hours. Every year you need to have some CPD hours to do training, right? So they attend because of that lah. Huh? What's that? Same for you, so yeah lah. Sometimes some company send for training, right? So something similar lah. So they also have that. And the 3 lecturers, when I talk to 3 lecturers, I teach them 5 days training. The 3 days they are okay only. Because all digital, whatever you learn lah, timer, all that timer, so they can understand HMI. But the moment I get go into the analog, all that, for them also is a text training. Okay. Then I talk to them, they say they can't teach only the PLC. They must combine. So there's one lecturer, they teach PLC and robotic together. So that's why you cannot cover more on PLC. There's another lecturer is PLC and pneumatic together.
They just cover the surface.
Cover the more theory lah, more to theory. Theory, what is PLC, the scan time of the PLC, all that. Actually, that one not very important.
To us, there's need to hands on. The one is
That one
it's good to know. It's good to know.
It's good to know.
Yeah.
The scan timing, everything. But when you want to learn, that one is not.
You cannot hands on. You cannot apply on your daily job.
Yes.
Help you to solve the problem.
Yes. So you go into the programming, understand the software, how the software works. You need to know how to use the software, what are the functions you have.
Yeah.
So you see, let's say, whenever you do, right, sometimes I go to the monitor, the controller tech, I go to monitor, right? Because that's where I can get all the values. So whether like just now I put some value, right? So most of the time you will go there and see whether the value is there or not. And sometimes you use the watch table. It's when you use the watch table, right? After this, you use a lot of watch tables. Use the watch table. Then there's another function called cross reference. That one later I'll show you.
Oh, that one, I know.
You know, right? To find where is my
You will
input
use
output.
that for troubleshooting.
Yes, that is very important for troubleshooting. So that one later we.
So monitor tech we can key in the value, right? But
Yes.
watch we just
Watch also can key the value.
same.
Yeah. Monitor means it will monitor the whole thing. Watch means
Oh,
it
not
will only watch what inside the routine only.
can you pick the routine first?
Routine.
Just on that side. Pick the routine.
You pick the routine here. The scaling FBD, for example.
Okay.
So it will only show what inside the routine only. The quick watch is you manually choose which one you want to monitor. So you can choose which one you want to monitor. You can key into yes. Let's say the temperature to scaling. What up? Okay. So you can pick the value.
These like favorite, right? Something.
Yes. Which one you want to watch, monitor, and also you can change the values.
Can change
Yeah, of course, just like you use the for the max function, you manually key in, right?
and watch it.
Yes.
So can he monitor that
Monitor is the same thing, but it will monitor the whole
everything?
everything.
Tapi bila you dapat projek yang banyak untuk kita
So
Too
many.
many.
So prefer to use the watch table lah. Okay.
Good.
Now, go to this scaling lah. Let's say like you don't want to use the FPD. You want to use something like this.
This one.
Okay.
Okay. So let's say you have 10 analog inputs.
Okay.
Right.
There's a lot.
A lot, right? So that is where we can use the add-on instruction. Add-on instruction means you create your own instruction. Let's say like you prefer ladder. You don't like the FBD. Okay? You prefer ladder. So you add-on instruction means you create your own instruction like this. So in ladder, don't have scaling, right? So I do my own scaling then.
Okay.
Okay. You right click here, you go offline. Okay. New add-on. Okay. You put scale. You put scale AI. Then the type, you can use ladder, you can use function block diagram, or you can use structured text. What I want to do is I want to use a structured text. Yes.
Okay.
Okay. Click OK. Okay. Under the structured text, can you see the parameter? You go to parameter, you key in. Just now you see the in FPD, right? You have a scale block, right? Input raw, all that. I want to create something like that, but my own calculation. So to do scaling, of course we want to do this calculation. Okay. So to do scaling, we need the analog input, input AI, analog input. Here, yes. Okay. So the usage is the input. Okay. Then here you put integer. INT. Then you click here. Then you put Y max, Y min, X max, X min. Y max, Y min, X max, X min. Just that name, no need to specifically for AI. Okay. All these input and data type is real. Okay. Then after scale, I have an output, right? Scale output. Okay, you put the name scale out. That one also real. And the usage is output. Usage is output. Here, output parameter. So when I want to do a calculation, right, scaling, I need so the Y is the scale out, the final value. X is the input, the analog input, Y max, Y min. Okay. So I need another two, right? M and C.
Okay.
So M and C will become a local tag. Okay, you do first, I will tell you. Do first, I will tell you. Okay. So for the M, you put a gradient or rate. Rate or gradient?
Rate.
Rate, R-A-T, rate, yeah. They call ratio, ratio or rate, okay. M. Okay. Then it's a real and also offset. Okay. Real. Okay, okay. Okay. Now, can you see? I have add-on instruction that is called scale AI. Yeah? Okay. Now, you add one run. You add one run here. You click on the add-on. Here, add-on. Can you see your block is the scale AI? Okay. Sorry, I forgot some things. You right click here. Right click the scale AI. Properties. Okay, go to parameter. Okay. This one, I choose the required. All choose required. All this. From the from the enable only from that yes. Okay. Okay, click OK. Now I choose the add-on. Click here. Just click. Okay, you see when I choose required, then only show up here. Okay. Okay. Then can you see the rate and offset is not here? Correct. Because the rate and offset I choose as the local tag. So it will be inside the block only. Okay. And others all I choose as a parameter tag. All these as an input, this is as an output. Okay. Okay. Now you give a name for this. You put a scale new tag, scale analog one. Okay. The data type follow your name. Data type it will follow your add-on name. Okay, so that one don't change it. Okay. And now here I can choose my analog. I use the same one. The analog input channel 0. Put it here. Analog input channel 0. Yes. Okay. So what Y max? Y max is 100. You key 100 value. Okay. Then Y mean the Y mean you put 0 to 100. Okay.
This one is
Negative 50. Okay. 100 put negative 50 also. Enter. So X max is 10,000. X mean is 0. Okay. Scale out, you create a new tag. Temperature what? 3. Temperature scale 1.
this we use structure text.
Yeah. Okay. Now you know what I have to do. Now I have two analog input, right? You go down, you add another you add another AI, the scale AI, the add-on. This one I can do for the second one. I can do this for the second analog input.
Oh, I see.
Means I only create one block and multiple times I can use.
Then when you have to change,
I just play with this one for this.
This one only lah.
Okay, so you put scale analog to the name. Then the analog input you use the one thermocouple swap. Analog input channel 1 temperature sensor. Yeah. Okay. So this one Y max is what 100. Y min is 0. H max is 4,000. Sorry, 20,000. X min is 4,000. Then you create a new tag. Just enter the value. Okay, good. But we haven't created a logic yet. Correct. Means I just made it up. So you see, if I want to create this one, I don't need logic yet. The most important because this one follow what I put in the parameter and local tag. Now I go and create the logic. Go and create logic. I use structure tags. Structure text very straightforward, you just type like this one is enough. Okay. So first you put two slash and a slash. Okay. Just put two slash. The other slash. Yes, okay. When you put two slash, you can put some name there. Okay. So you put because you want to calculate, okay. Calculate ratio or calculate rate. Enter. Okay. Now, so just now it's a rate, right? What is your parameters? Just now in the parameter you create. You make it smaller. You bring it inside. Yeah, make it smaller. Yeah. Okay, you use this one to create the logic here. You follow me. Because I want these names, okay, so that. So what is your local tag? The local tag is what just now? Rate M, right? Okay, put it here. Rate M underscore M, because here are very difficult to choose from the tag. Okay. 2 dot equal open bracket. Okay, you do this one. Y max minus Y minimum.
This one key or
No, yeah, key. You cannot select unless you copy paste. Okay, copy paste that. But I want key minus Y minimum. Close bracket. Divide. No, the other one. Open bracket. X max minus X minimum. Okay, close bracket. Okay, semicolon. The dot and comma. Enter. Okay. Then you put again like this. The 2 slash, you put calculate offset. Calculate offset. Okay, enter. So the offset C offset underscore same 2 dot equal okay Y minimum minus open bracket M is what? Rate M multiply X minimum. X minimum. Okay, close bracket, semicolon. Okay, enter. So last one is the okay, calculate output. Calculate output. Y, calculate Y. So Q. Enter. Calculate your analog. Or you put calculate Y is what actually calculate scale out actually. Scale out. Okay, enter. So you do that. Y is the scale out. E dot equal open bracket M is the rate M multiply okay, then this one, this name, analog input, because your X is the analog input. Semicolon, sorry, plus C, plus offset. Okay, that's all. Okay, so actually this one is similar what you created in the CPT.
Oh,
Correct?
yeah.
Because this is your destination, this is the expression.
But it's just like normal programming lah. Everything is end column and you got comment on top there.
Yes,
Double slash is comment apa.
yes. So if you don't want other people go and kacau your program, all that, right? You can do something like this. So because this is the one, it's exactly same as my the compute CPT. Same thing. Okay. Close. Okay. Then go back to your scaling. Make it bigger. So whatever program inside here is actually these three calculations same.
Okay.
But actually I can do like this the CPT inside the scale also can. Because this the logic, right? You can use ladder, you can use structure test, you can use FBD also there. It's different. Just now, I don't want to use the same ladder. That's why I'm to show you this. Okay. Now you download. You get the value, right? You get the accurate value. Okay. So you see, I show you 3 ways to do scaling. One is using the CPT. One you can use the structured test. Even here also you can add a structured test. Whatever I do, I can do that.
Structure test is more easier.
Yeah, of course. That's why I say, whenever I do,
Feel like some
calculation I do on structured tests. So easy.
easy. I felt like familiar with.
Yes, yeah. Because it's like a basic C programming. Okay, but if you ask me to do whatever we learned on the first 2 days, start, stop, motor, timer, all that, right? I prefer like
Not straightforward.
straightforward. I do it later. Because structured texts are very difficult because you need to create a case if, then, else, all that. Okay. Now, and scaling even you can do in the function block diagram. So you can. After we do all this scale, right? What we do actually? Go to counter program. The counter program, I have this right. And so once it's a 2 come up, then once I reach the 10, once I reach the 5, I will reset the counter, right?
Okay.
For example, okay. The temperature, I can use the temperature value also to reset the counter.
Just a sensor lah.
Yes.
As a reset.
I can use as a reset, even I can use as a sensor also can. Okay, we see how. What I want to do is, when the temperature, the one, the potential meter lah. When the potential meter reach 75 degree, I want to reset the counter. So, just now we do scaling, right? Actually, why we do scaling? Because I get these numbers. We call it as a raw value, right?
Okay.
I get this raw value. I convert back this raw value into the unit of my device. Actual value lah. Okay. Because only there's a 2 reasons. One, I want to show in my HMI. If I don't want to show in my HMI, one I show in the HMI, or I say I don't want to show in the HMI, I use in a compare function. Comparison. Okay, so that's what I want to do. So what we do, we go on. Okay, only offline lah. Just double click here. No. Just double click here. Okay. Can you see there's a compare function? Okay, what compare? Okay, can you see got if you don't care this one or later we understand later we see. For now, equal, not equal, less than, greater than, less than, equal, greater, equal. All this.
Like a no get.
What's that?
Like a no and don't get.
Yeah, correct. So you put a greater GRT. Okay. No, I want to put, you put a branch here. No, the one we do. You put add a branch. Add a branch here. Yes. Then you bring this GRT greater drag put it here. Okay. So means I press the reset, I reset the counter, or if the temperature is high, I reset the counter. So you need to understand. You see, this is the block, right? But can you see it's on the left hand side? Didn't go on the right hand side.
Okay.
Okay. Because this block, this compare block is similar to your normally open. Same like a normally, the function is same like normally open. How the normally open work? When the value from 0 become 1, I give the signal. Same. This one also same. This one is when source A is greater than source B, I give the signal.
Okay.
Okay, because in Allen Bradley it look like this. In Siemens, if you look like normally open. Okay, but in Siemens when we learn it's
But it's just the same thing lah.
the same thing. That's why I will tell all my participants, the compare is actually is a normally open, but with the condition. And the condition is greater, less than, or that. Okay. Now here I put the temperature value. Just now I do scaling, right? The temperature value I put it here. You choose from here. Okay, which one? Go down. Go down. There's some long names. Use this one for temperature one. First one, yes, because that's one from the potential meter, right? So we use the one we use for the from the add-on instruction. From the add-on. Yes. Yeah. Okay, how much? 75. Okay, put 75. 75.0 lah, because it's a real, right? Okay. Enter. That's all. Finals. Okay, reduce first. Okay. Okay. Now you sensor one you on 5 times. Push button. No, your push button. Yeah. That's one count 5. Now go to 5 times. Okay. Now counter is already done. The lamp is on, right? If you press, you can reset. Or you increase the temperature more than 75. I can reset.
Okay.
Okay, you can. What I can do, you add another round. You copy this. Copy instruction, put it here. Okay. Then you put 90 degree. Okay. 90 also can, 90.0 also can, not that issue like calculate. Because if you put 90, right, it means it's an integer. Other decimal point. 90.0 means it's a real. So that's how the PLC is. Okay. You put one output here. Okay. New output, which one not in use. So you create new tag. You put the red lamp, the last one. You put red lamp. Then alias. You choose the alias here.
Right.
Then you choose the tag. Local 2 output 5, right? Local 2 output 5. Data. Yes. Okay, clean. Okay. Finalize. Go more than 90. More than 90. Okay, the lamp is okay. So after scaling, right, this is what we do. Compare this.
We can control the precise value.
Yeah, of course. From using the compare to control our sequence lah. Temperature high cut off this, temperature low on this.
Okay.
All all this. That is what we do scaling. Without I do scaling, see, can I do this comparison now? Can I list this? Let's say that the last, take the last one is easy to understand. The red line one. So what I do here is I choose greater the temperature value with the 90 degree, right? Okay. Then I'm on a red line. Correct. Okay. So I use the temperature value, temperature 90 degree. Can I on the red line without the scaling or not? Because this one I get from the scaling, right? After I do scaling, then only I get the temperature value. If I didn't do the scaling, can I get the temperature or not? Can. Still can. I will show you how. Great. You adjust to 90 degree. Now you adjust to 90 degree. 90 plus minus, okay. Okay, leave it 91 is okay. No problem. You go to the scaling. 91. If your analog value is, the temperature value is 91, what is your raw value? 9490. Right. It means 9400 left hand. Means, so what I do, instead of using the result scale value, I use the actual value, which is my analog input channel 0. 90 degree is equal to 9400.
Oh, so I have to see the raw value.
Raw value.
What have we need to trigger that
Yes.
one?
To get right.
So we just fill in something greater than that.
Yes. Because I'm using a raw value. So I must use the raw value. So actually, if I didn't do the scaling, I manually go to use my handphone to calculate 90 degree is equal to what is the, because I use this one, right? I use my handphone calculate to get the 90 degree, what is the raw value? I can use this also. If this one also, the land will fall.
But it
Depends on use case. Depends on use case.
Depend but what happens is, if I do this, let's say I don't want to show the temperature in my HMI.
Okay.
Right? So actually I don't need to do scaling. Correct?
True.
Don't need to do scaling. So I do manually in the calculator, I use do, and I straight away use the analog value, the raw value with the raw number, because this one is equal to 90 degree, right? This one is equal to 90 degree. Okay. But in the future, someone want to go and change. For him, it will be difficult.
you need to count.
He need to do accounting again. Let's say in the future, I want to change from 90 to 92 degree.
Recount.
If I do this program, I just straight away go here, change the 90 to 92. If this one means the new guy need to calculate again. So 92 maybe, if 92, I think some maybe 50 for example. I need to do some calculating. So that is the reason we do scale. So because whenever I teach analog, people think analog is tough. Okay, of course, because analog is value, everything, calculation, something. But what is the real function of the analog? Because I get the raw value, I change into a engineering unit. Engineering unit, what I mean is this one: temperature, pressure, your motor speed, all that. Then for us to do the program easier for us. So later, if I want, when the temperature is 90, okay, I want to on the red line. When the temperature is go below 70, I want to on the orange line. When temperature go below 50, I want to on red green line. Or if the temperature more than 100 already, I give alarm. All that, mostly I use compare. Analog only two things after do scaling. One you show in the HMI or you do compare. These two only.
Because sometimes you want to trigger something.
Yeah, of course. Okay. So that is the analog way. Analog. So there's a many way to do a scaling lah. So it depends on you which one you want to use. For me, the scaling FPD is much more easier because they already have a block. Mostly all PLC have the block. So normally they will use the block only. But LMLE programmer mostly use the CPT. If only one if got many, what I do, I take the CPT, I put inside the add-on instruction and I create like a block like this. Then I use this. Sure, in your program they use a lot of add-on instructions. So not only for scaling I can do, repeating things, anything that is repeating. Like let's say you have a 10 motor, start stop motor with a timer, right? You need to create 10 motor logic, whatever. First motor logic, second motor logic, you get only one logic inside the add-on. Then make that add-on into a block like this. And each one, this one, all the motor one data. All motor one data. Sure, must have one. Then sometimes the add-on instruction, some of the special like mod bus. If you want to do a mod bus, if you go and find here for mod bus, you won't get.
So
You have to go and right click here. Right click on the add-on. Can you see there's an add-on called import?
Okay.
So you can import from the website. You can download from the website. Rockwell website. Some special functions, right? Then you can download from the Rockwell website. Just import, then you can use. For Modbus, you need to do that.
And some other it's not.
Yeah, Modbus is one of the examples. Even you can create your own add-on. Like for example, just now I create the logic, right? Inside that, you can create something which is very complicated. One. And you export and you can keep,
For another use.
For next project you want to use, you can use yours.
You can keep as a text.
As a text.
For the logic. You can copy out, then keep as a text. Then after you need it,
Try export.
You can directly, you go off slide. You right click this AI. Export add-on. You can directly export this AI. Block.
that particular
This particular instruction.
okay.
So that is your instructions. Yeah, you become L5. Become the XML file like yesterday. Then later for another project you want to use, you can use it. Because even you can put your name also, You put the after you do this one, you put the property, even Siemens online, they also have something like this. Because Siemens one, this one they call function block, FB.
Function block.
FB. In Siemens they call function block.
There's function block, there's
FC. OB means is your main routine.
Main routine, right?
FC means is this one, like subroutine. FB means is the add-on instruction in Siemens.
There's a lot of block.
No, there's another type of block called data block.
Data block for
Data block is something like your controller tag. But it's a specific tag. Whenever the one when we learn analog, when we learn Siemens phase. You right click the scale block. No, scale AI. Go to property, can put revision, you can put, and you can put the vendor. You can put your name.
Oh,
Who create?
okay.
Yes. Sure, in your system, all sure will have a name. Then you go to scan mode is normal scanning, right? Okay, how you want to scan the data. So it's like continuous scanning. Go to signature. Signature. Yeah. This one is like you create your like a log lah.
For this add-on only lah.
Yes, you log the add-on.
For PLC,
What's that?
for PLC simple signature.
PLC one the day we see that security.
Security,
Yeah.
simple signature doesn't generate the simple signature.
See, I don't think so. If you create a signature, it will create like a password.
Only a password.
Only password. So if you have a password, of course you can edit it.
Ah,
But this one, you need a signature to edit. If you know, you can edit something similar, but they call it signature. Because in Siemens they don't have. Siemens is like normal password only. If you know the password, you can edit. If you know the password, you just use it. You cannot edit.
okay.
You need.
You only lah. Okay, good. Whenever that is saved, and okay, continue to mode. Now I need to go to a company.
What did they do here?
No. I told them already, only after 5 only my class finish. After 5 only I can come.
Yesterday, you went there?
No, not yesterday, today. Now from here, we can go there, so almost it takes like 20 minutes. I told them already I will be there before 6 lah. Just for a while, just go and but I don't know lah how long going to take. Because once you finish, need to test first.
Easily.
I don't know whether they already connect the cable or not. That's the problem now.
Remotely you go there?
Huh?
You remotely at home or what? Or you have to go
No, I
there?
need to go there.
Need to go there, yeah?
I need to go there. Because I don't know, because they're not very familiar with this PLCs. So sometimes I ask a question, they don't understand. So very difficult.
But you go KL for verifications.
What's that?
KL area for verifications.
No. I go only cheap Johor. Really under kilometers. Last time someone calls us. So last time whenever we tell them okay, but if you want to come, okay, if you want to come and check only, you need to pay us. Right. Then you can swap, then it's a different charges lah. Sometimes a few times they say no, you come and check first, you come and check first. Then I say if I go then they didn't pay me to eat for me.
Betul.
So I need to go and they need to stay there, right? That's why I don't.
Sometimes the end user doesn't want to set anything.
Yeah.
After they hide something,
Yeah.
they're not being honest.
Okay.
Alright, see you tomorrow.
Thank you.
Okay.